Hello and welcome. This is Precious from Clickate Academy, and I'll tell you that I'm very delighted and ecstatic to have you in this training series for C. I hope that you follow through and will be able to get through to the end. And let's get to business. So, what is C? C is a general purpose programming language that was created by Dennis Ritchie at the AT&T Bell Laboratories in 1972. Now, Ritchie created his newly developed language simply because there was a programming language called B already. Interesting, right? In short, B was the reason C was created. Now, C is a high-level programming language, and in fact, C is one of the most popular general-purpose programming languages. It is very popular, yet, although it is quite old or very old. Now, C is strongly associated with Unix as it was developed to write the Unix operating system. And right here is a diagram that will just show you the basics of how C works. So, when you write your source code in C, you write your codes, C will need a compiler that would help you to convert what you have written to machine code. So, your machine or the machine cannot understand your source code or your C code immediately. So, it needs a compiler in between to be able to do that. In the next video, I'm going to show you how to install a compiler and do all the settings. But here, let's roll on with our introduction. So you may ask yourself, why should I learn C? Well, C is one of the most programming languages in the world and it is easy to read. So why shouldn't you learn it? And if you know C already, you would have no problem learning other popular programming languages like Java, Python, C++, C#, because the syntax are almost similar. Is that not good news enough? Now, C is very fast compared to other programming languages like Java and Python, and it is easy to maintain. That's like a very good point, for a language that has been very old. C is very versatile. It can be used in both applications and technologies. In short, most operating systems like Windows have an element of the C programming languages in them. So you can use C to create operating system, desktop applications, all sort of applications, computer applications, anything you can think of, C, because it's the base of most programming language. C is very portable and you can port it to different computer platforms. I would have loved to end this video here, but I just want to tell you the differences between C and C++ because people tend to confuse both of them. So, difference between C and C++. C was developed as an extension of C. And both languages have almost the same syntax. So look at it this way. C came out first. C is the basis of C++. So when you have the language C, then an extension was created called C++. That is to say, if you understand C, if you follow me through the end of all these videos and you understand C properly, you would have no problem with C++. Also, the very main difference between C and C++ is that C++ supports classes and objects while C does not. What this means is C is a procedural language, that is, it starts executing its code from top to bottom. So C is a procedural language, but C++ is an object-oriented language, or it operates on object-oriented programming. That is, you can work with objects and classes in C++, but you can't do that in C. That is just the major difference. So, a lot of talking, right? Like I always tell you, I prefer practicals to theory. So from the next video, we would see how to install our text editor and how to install compiler and how to work with our first line of code. So I'll see you in the next video. Precious out. Hello and welcome to the series C Language Programming for Beginners. If you watched the previous video, which was the introduction, I believe that is why you are also here. Now, we need to get started with C. But before we get into the code, we need to get some things ready. So to get started with C, you need two things. You need a text editor like VS Code, CodeBlock, or Notepad, which you use to write the C code, and a compiler like GCC. The compiler helps you to translate the C code into a language that the computer will be able to understand. Remember from our last illustration, a compiler is the middleman between your code and the understanding of the computer. So there are many text editors and compilers to choose from, but in this tutorial, we would be using the IDE called VS Code. So what is an IDE? An IDE is an integrated development environment which is used to edit and compile your codes. So popular IDEs for C include CodeBlocks, Eclipse, and Visual Studio Code. They are all free and they can be used to both edit and debug C code. But in this training, in this video, we would be using the VS Code called Visual Studio Code. Also, for our compiler, we will be using a compiler called MinGW, which has GCC pre-installed, which will help us to compile all of our C code. So, let's get to it. Hi and welcome. This is Precious from Clickate Academy. In this video, I'm going to show you how to install a C compiler in your Windows computer that you can use with your Visual Studio Code editor. The C compiler we'll be installing is called MinGW, and I'm going to put a link to this page where you can download it from in the description for this video. The next thing you need to do is come over to this section. The first one, you don't need the first download because it comes installed with Git. We need the second one because this one does not have Git. I believe you should have Git installed on your computer already. And if you want a very comprehensive video on how to use Git, please check out one of my previous videos on Git. So click on this to start the download. Personally, I have downloaded this program already, so all I need to do is just to open up the folder for my programs, for downloaded programs, and start the installation. So let's do that. So I'm going to install this in my C folder. So delete everything you have here and change whatever alphabet you have here to C. That's all. Then extract. So the extraction will take a little while because it's extracting a pre-installed program. So let's give it time. So the reason why you need the MinGW is so that you would be able to run your C programs on your computer or on your Visual Studio Code editor. Because the compiler is what is going to interpret your codes to the computer. So it's like an interpreter for the computer to understand the commands that you are giving to it. That is the major importance of getting this program. So now that you have it installed, let's check where it is. So remember, I had mine in C. And this is the folder, MinGW. So open this folder, open the bin folder, and copy this link from here. Copy. Why do we need the link? Because we need to add it to our environmental variables on our computer so that we'll be able to use the compiler everywhere on the computer. So click on the Windows icon and search for environment. You don't even need to type it completely because it will come out. So this one, edit the system environment variables. So click on it. So you have it open here, the environment variable. But before we continue, let's go back again. Click on your C folder, MinGW, open bin, and click up here and copy this link. We want to put the link in our environment variable so that we will be able to access the compiler all through our computer. So open up the environment variable again, click on this button here, environment variables, and on the first one just below user variable for Precious Iriaevho, I don't know, your computer would have a different name, click on edit, then click on new, then paste it with Ctrl V. Click OK. Also come down and do that for system variables. Click on path, click on edit here, click on new, and paste with Ctrl V. OK. Close the system variable by clicking OK. Now the next thing for us to do is to test to be sure that we have the C compiler installed properly. And how do you do that? Just search for CMD, that is command prompt, open, then type GCC version. If it's installed, it's going to tell you the version. And yes, we did that correctly. Also, the next one, G++ version. If it's installed correctly, it tells you the version. And there you have it. Our installation was done properly. The next thing for us to do is to install the Visual Studio Code editor. Personally, I have it installed on my computer already, but if you don't have it installed, then this is how you go about it. Visual Studio Code, you search for it on Google, then you click on the link here that says download. So depending on your system type, you will find different links to download, but mine and I believe yours will be Windows, so you click on this for Windows to download the one for Windows. So when you complete your download, just start the installation by double clicking on the file, and don't forget to check the box for add paths to variable. Now when that is done, open your Visual Studio Code because we need to put in some extensions. To add extensions to your Visual Studio Code, click on this icon that has the boxes, and the first extension we will install is called C++. Just type that with me. I have it installed already, but I believe yours will not be installed already. So when you get your search return here, you will see a button like this that says install in front of it. Click on that button. Ensure it is from Microsoft. So you have something like this, then you click on install. Then the next extension we would install is called Code Runner. I have it installed too, but yours may not be installed, so it should be from Junhan. Also click on install to install it. When that is done, the next thing for us is to test our C program. So let's do that now. Let's write our first C program. To do that, just click on this icon that says new file. I'm going to call it hello.c. The file extension should be C because it's a C file. Enter. And let's type a simple C program. std.io h int main printf hello my friend. The next thing for us to do is to save and to run our program. To run this program, you just click on this icon here, this play icon on your screen, or you use Ctrl-Alt-N. So I'm just going to click on this button here to run this code, and let's see if our compiler is already working with Visual Studio Code. And there you have it. It's working. It says, hello, my friend. Let me change it to something else. Let me say, my name is Precious. and let's see. Oh, I didn't save that. So save, and let's see, check what happens here. And you can see the new code has been outputted. My name is Precious. So our C code can now be compiled in Visual Studio Code, and we can run it properly and get our return or our output. So that is it on getting your compiler installed on Visual Studio Code and ensuring that it runs properly. So there's another problem you will face with your C program and the compiler, and that is when you are trying to get user-generated input. Let's try it and see. Let's create a file called input.c. I've written this script already, so I will just paste it here. It's a simple script that asks you to enter your country, and it tells you that your country is whatever country you imputed. So let's run this script. As you can see, the program has run successfully, but there is no output. There is no way for you to put in your country. So let's end this script. Let's end the terminal, the script running on the terminal, and redo this. Use Ctrl-Alt-M. So for you to solve this problem, all you need to do is click on File, Preferences, and Settings. Then here, search for Run in Terminal. And scroll to the bottom to where you see Code Runner, Run in Terminal. Click that, and that's all. So let's go back to our scripts and let's run it again. And now, as you can see, it says enter your country. I am from Nigeria, so I'm going to put that in there and click enter. And as you can see, it says your country is Nigeria. So that's that on this video on how to install a C compiler called called WinGW on your computer, on your Windows computer. Also, I've been able to show you how to install Visual Studio Code and how to create your first C program, and also how to solve the issue of not being able to put in an input into your Visual Studio Code from an output or a response or a script from your C compiler. So that's that on this video. I'll see you in the other videos that teaches us how to do more great stuffs with C. See you. Hi and welcome. I wanted to make this video quickly for those who would want to run their C program in command prompt. So currently, as you can see, we do it in Visual Studio Code. So if I click on run, you can see the output, hello my friend, just like what we said in the printf right here. But in case you want to do it from your command prompt from File Explorer directly, you can also do that. So let's get to it. So let's go to the File Explorer, to the folder where we are working in. So this is the folder. Let me delete this. This is from Visual Studio Code. So this is the C program we have, the one with the hello my friend. And if you want to open or run this file with your command prompt, come to the search bar here and click CMD to open command prompt. And once it is open, the next step or what you need to do is say GCC, then the name of the file, hello.c, enter. Now, this file has been compiled there immediately by GCC, and as you can see, it has created an executable file for you. So for you to be able to get the output from this hello.c file, the next step is for you to run the a.executable file. And how do you do that? You say a.exe and enter. And as you can see, we have our output here, hello my friend. So basically, this may not be relevant for you But I just feel that you should know it because we are doing a lot of stuff also with command prompts or any other terminal. So I felt instead of just doing it all on VS Code, you should also know how to do it with command prompt directly. So thank you for watching. I'll see you in the next video. Hello guys, it's Precious again, and we are moving smoothly. So in this video, we'll be writing our first line of code, and we'll try to understand the syntax of C by explaining everything that we type out. So the first thing we need to do is let's create a C program called Hello World, because this is going to be our first serious code in C. So I'll call this 001. This is so that I want a proper arrangement of all my codes so that I can send them to you or you could download them later on. So 001 hello world .c. All your files should end with .c. Now, in our hello world file, we are going to write a proper C code. And the first thing you would write in any C code is you have to use the include. And what does include means, or what does include does? Include is your preprocessor keyword, and it's a directive that tells C to look for a particular file in a location. It does some preparation before your code is compiled. And an example of a file that you put inside of that an include file is going to pull out for you is the standard input and output header. So this is a file that helps you to perform a standard input or output response. So let's go. So we are including std IO, which means standard input or output .h, which means header. So we are including this header file that will help us to perform simple input and output processes. Now, you may ask, why the angle bracket? The angle brackets tell C in which folder to look for. So when you put your angle bracket here, you are telling C to look for it inside of another folder instead of the current one. If you installed mingw, you would notice that your include files are inside of this folder. So let me look for our include files. If you go to, I installed mine in C, mingw. So this is what we are calling include. And include is going to look inside of this folder and look for that file that we are telling it to look for. So if it's stdio.h, it's going to look for that file inside of this folder. All right. Now let's go back to the program. So if you put an apostrophe here, then you are telling C to look for it inside of this folder called C file where the program is being typed initially. Instead of before it goes out, you are telling C to look for it here. But we don't have it here, so that is why we don't use this. C is going to look for it in the default include folder. And that is why the angle bracket is there. The next thing is every C program must have a main function, and this is how you write a function. I will show you very soon why int may not be needed, but we could always leave it there. The main function, every C program must have a main function, and it shows that the execution of a program starts and ends with a main function. And for every program, you have one main function. So everything that we are going to do will be inside of the main function. All our program will be executed inside of the main function. So let's write a simple code. Print F. Print F is how you output stuff on your C program. It's for outputting. Now, let's type hello world. Then the next thing you need to know is the return. All C program must come back with a return. So return 0 means that this program was run successfully. Return 1 or any other response means that the program did not run successfully. So when you have 0 in your output, it means that your program ran successfully. You can send in other type of response, but 0 means your program was run successfully. And it returns a numeric value, 0 or 1 or whatever. That is why you have to use the int here. So if I take out int and I run this program, you see that it still runs. But it is important that you put the int so that the program knows that the data type, which we will explain in upcoming videos, the data type is a number. So int main hello world. But before I close this video, I also want to introduce you to another command that is used to complete the execution of a program, and it is called the exit keyword. So to use exit, we have to include another file, and that file is called standard lib std, standard library, I suppose, std lib.h. Then we can use the exit. So exit is used to stop a program. Let's see it in action. Let's say I have two hello world. So the first one is hello world, the other one is hello world precious, right? Save. Let's see what it outputs on our program. As you can see, we have both of them. We have hello world and we have hello world precious. But we can use exit to ensure that the second printf does not run. And this is how you do it. You put in exit. You also send in the response 0. Close it and save. And let's see what runs on the terminal. Just watch the terminal, the output. As you can see, we only have hello world because we stopped the execution of the program here. We exited out of the program. So this one is not going to run. You can also send other kind of output. 1, save, exit, and you see it still runs, but you see now your code says 1. Previously your code was saying 0, but now the output says 1. So you can use exit and return interchangeably, but exit is going to stop the execution of your program, and to use exit you have to include the stdlib.h file. So that is that on your first program in C called hello world, and I've been able to explain to you the syntax, how to include, why you use main, why you use the angled bracket, and why you should use the return and the exit keyword. So I'll see you in the next video where we'll go deeper into C programming. Thank you. Hello there and welcome to this video. In this video, we'll be talking about comment and escape sequence. So let's create a new file, 002 comment escape.c. So let's clean this up. I just pasted this from our hello world program. Now, you would realize that in your code, you would like to leave comments. I mean, it's okay to leave comments in your code because it helps you to remember maybe something that you've done previously, or to leave messages for other developers. So, to use comments in C, the first type of comment is this. It's called single line comments. I'll say, this is a single line comment. And the things about comments is that comments would not be executed with your code. So let's run the code and see if it's going to be executed. Hello world, you see your comment was not executed. What if we move it into the main function? Remember we said everything inside the main function will be executed, right? So let's put the comment there. This is a single line comment. Let's run it. You see, the comment was not executed. You could also have a comment in front of your code, something like this. I said hello to the world here. Save. Let's see if it's going to be run alongside the code. As you can see, hello world again, because the comment has been excluded. So anything you put inside of a comment would not be executed with your code. There is another type of comment that is called the multi-line comment. To write a multi-line comment, you use the /, then asterisk, and let's do it. This is a multi-line comment, and you close it again with an asterisk and a /. As you can see, it's a long comment. This is it. Let's see if it's going to be executed with our code. So you see, it was not executed with our code. If I copy the entire comment and let's say I put it right here, let's execute the code once more. As you can see, it was not executed with the code. That is how to write a comment in C. Now let's take this out. For escape sequence is important, especially when you want to create a new line or you want to create a tab in your code. Imagine we have another printf, hello world to you. Let's have another one, hello world to you, my friend. That is 3 printf. But if we run this code, let's see what happens in the terminal. Oh, I didn't save that. Sorry. As you can see, they were all printed together. And that is where the first escape sequence comes in. So let's use a comment to write about that. The first one is n. This creates a new line. And let's try it out. So to create a new line, instead of having what we have on the output, let's put this here. So we say /n, and let's put it here too, so that we have it on one line each. Save, and let's run the code again. And as you can see, our printf now appear on one line each. Is that not pretty? Now, there is another one you would like to use, and that is the tab. So, to get the tab, all you need to do is T. This is a tab. So let's assume that we have numbers. And numbers mostly, we just have 1, 2, 3 together. 1, 2, 3. If we save that and we print, you see that they are all together. But what if we want to create tabs in between them? Yes, you got that right. T, and save. Let's run that. Now you can see that there is a space in between them. Now you can play around with this using tab, using /n and /t, and let's do that. So we can say, now new line, let's create a grid, then this will be 4, /t, 5, /t, 6, then a new line, /7, 7, /t, then 8, /t, then 9. So you have 1, tab 2, tab 3, new line, 4, tab 5, tab 6, new line 7, tab 8, tab 9. Let's save that and let's see what we have. As you can see, we have just created a grid of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's assume we want to make a quote. How do you make a quote? Remember, in your printf, you have to always use the apostrophe. So let's assume we have a quote. You use / apostrophe to escape. So let's make a quote. And this quote was made by, let's say, me. Yes, I made the quote. I love programming. Then you have to escape the next quote. If not, your program is going to run it with the code. The reason for escaping is because our printf needs to be inside of an apostrophe. So imagine you have another apostrophe. Your code is not going to run. There will be problem there. Let's try it out. Let me remove the slash and let's see what happens with the code. Now we have the quote, I love programming, right? Let me clear this. You see, we have a problem. It's saying I love programming, but it's showing you the arrow that there's a program here. We've not escaped it. So let's escape with / apostrophe, / then save, and let's run the code now. And as you can see, we have our quote. I love programming. Precious Iriaevho. Also, you can escape a /. So this escape /. So that means if you want a slash inside of your program, you have to escape it. So let's say 3 slash. I mean, it means nothing, but I just want you to see that if you want this to show, you have to make it double. And you see 3 /6. Because if you leave it alone, it's going to be a problem with the code. As you can see, there's a problem. So you have to make it 2 for escaping it. So there are also different or many other types of escape strings or escape sequence like you have on your screen, or you can check the internet for more, but you would not be using most of them. They may probably be relevant for you, as you can see on the screen, but you can try them out and you can check for more on the internet. So I'll see you in the next video. Welcome, guys. In this video, we will be talking about variables in C programming. So let's create a new file called programming.c. Sorry, variables.c. Let's declare the header stdio.h. Then also let's create our very simple and basic function. Now, what you need to know with variables in C is that variables are allocated space in memory. So you refer to a variable name to access the stored value. And also, you have to declare the data type before storing value. So let's see this in action. So what this means is your variable is an allocated space in the memory. Now, when you have a variable name, that variable name is storing a value, and to be able to access that value, you have to refer to the variable or the variable name. But before you declare a variable, you have to declare the data type. Now, there are two ways to declare a variable. The first step is to declare, then you initialize. So let's assume we have a variable called x, and we are storing numbers. So integer x is equals to 1, 2, 3. What we've done right now is called declaration. After you declare, what we've done here is called declaration. So without storing anything, it is called declaration. Now, after you've declared the variable, you can now store value into it. And this is called initialization. But there is a faster way to do it instead of typing 2 lines of code, and that is you declare and you initialize at the same time, and we have this int y is equal to 456. And this is what we call declaration plus initialization. So most variables I will be declaring will be declared like this, by line 10, where we declare and we initialize at the same time. Now, let's create some series of variables and let's store different values into them. Let's call these variables a comment. The first one is age. Let's store a value for age is equal to 21. And this is an integer. The second one is a floating point number. So you use floats. So this is the data type, then 3.45. A floating point number is any number that has a decimal point. So let's call this GPA is equal to 3.45. And this is a floating point number. The next one is a single character. You use char to store a single character. So let's say char grade, that is in char means character, is equals to, and you use a single apostrophe. So this person had B as a grade. So this is single character. Now let's try to store a string, a series of character. C does not have the string data type, so instead you use what is known as a character array. So let's go char name, then you put this array symbol. We are going to touch on array in subsequent videos. Then you use double quotes. Don't always forget your semicolon. Very important. Your semicolon is important in C. Your semicolon is what ends your statement. So this is a array of character. And now that we have an array of character, let's print them on the screen. But before you print, you have to know something called a format specifier. I'm going to touch more on it on another video, but you just need to know what they are. So a format specifier is what makes it easy for you to access your variable types. So let's do the first printf. hello, let's refer to my name. So if I want to get the value of my name, I need to use the format specifier, then s. The format specifier for string is s, then close the apostrophe, comma, then the variable name. The next one, let's access the value of my age. Oh, I have age right here. Print f your fake, that's not my real age, your fake age is, format specifier for number or integer is a d. Close that, then write out the variable name that you want to access. Let's call out the GPA. Your GPA is, your fake GPA is, format specifier for a float number is f. Then you write out the variable name, GPA. And last but not the least, print f your grade, your fake grade is, format specifier for a single character is C. I will call this grade. Let's run this code and see what we get as our return, or what we get printed out on the screen. So I'll run it. As you can see, it's all out here. Hello, precious Iriaevho, your fake age is 21, your GPA is this, your fake grade is this. But I intentionally refused to do this before so that you would understand what is happening. Now let's use our new line. Let's use our new line sequences. So to put them all in a new line, we use /n just after the ending of the sentences, so that we can see them properly. Save and let's rerun this. As you can see, they are all on different lines. Now, what if we want to use them all in one complete sentence? So let's say print f my name is. Then you use this format specifier for the character s. My name is. I am, for age, D, because we want to bring in the age. I am years old. I scored, format specifier for the character C. I scored C grade in the exam. Then my GPA is, format specifier for the float is. Then now we need to arrange all the arrays just as the way they will appear. So the first one is name. So we have the variable name, followed by variable age, followed by the grade. That's the variable grade right here, and followed by variable GPA. So let's see what we get on our screen. I've used them all in one sentence. Let's see the return. Let me clear this and let's go over it. Let's do it. Oh, sorry. You see, always close with your semicolon. Very important. Close with your semicolon. It's good that you see me making this mistake so that you won't have to do it on your own. So let's rerun it. Yet to save. Yes. So close your semicolon for every statement, end it with a semicolon, then let's run. Hello, precious. This is the first one we did. The first three, okay, we converted the last one. Now see, your fake grade. Sorry. Oh, let's put a new line here. And let's save that. Let's clear again. And now we have it. So the first four that we did up here, this four is showing on the screen. But also the last one that we just did, the long sentence. My name is Precious Iriaevho. I am 21 years old. I scored B grade in the exam. My GPA, not GPS, my GPA is 3 point. My GPA is 3.4. Just for posterity, let me spell that correctly. Let me also spell this. I think I saw another mistake there. My name is, for posterity, let me spell that correctly. Now let me rerun it. So my name is this, I am this, I scored B in the exam, my GPA is this. So I'll see you in the next video. Thank you. Hello and welcome to Data Types in C. Now, in our previous videos, we've already started using data types, we've touched on them, but we've not been able to go deep into them. So let's talk about them. The first thing you need to know, the first data type is the character for single character. So you have char C, which shows you only a single character, and you have the one for array of characters that helps you to display a string, which is char B into array. Then you have bro, or let's make it brother. To specify them, you use %C and %S. Also, for your floats, floating number is used to display characters that have a decimal point. But also, you have double that is used to display characters that have decimal points. So, let's see something in action. Because the difference between the float and the double is that the double is more precise, but it uses more memory, while the float is less precise, but it uses less memory. And the float is correct up to 6 to 7 digits, while the double is correct for up to 15 to 16 digits, and that is what it can contain. So let me copy this number and add it to the float. Let's see what happens. So I'm going to uncomment the print for the float and the print for the double. Let's run this. Let me clear the terminal. So let's run this. As you can see, we have our results, but the numbers are limited. So let's make them long by adding these values in front. So what we do is when you add these numbers in front, it helps to show the numbers of characters that you want to display. So let's clear the output and run it again. Now, our numbers are displayed. But when you look at the one for floats, you can see that the number was correct up to 592. But after 592, it was no longer correct. It's that you have 6535, but we don't have that here. But for double, you can see it was correct till the end. So it goes to show you that the double is more precise and correct than the float. So that is basically the difference between the both of them. The next data type is called the Boolean. The Boolean reverts to true and false. So it uses just 1 and 0. And let's see that. So for the Boolean, But before we proceed, for you to be able to use your boolean, you have to import this header, include stdbool.h. So let's run that for the boolean and see what it outputs. So it outputs 1 because boolean is true. 1 is true. Let's make it false. And you see it outputs 0 to show that it is false. So there are other ways to show true and false the way it is, but we'll touch on that in subsequent videos. The next one is called the char f. Remember, we use char or character initially here, but you can also use it to display both characters and character, both integer and character. To use it to display an integer, you have to be between minus 128 to 127. So let's try that. Character as a numeric value. And let's display it. As you can see, we can display 120. But when you change the format specifier to character from D, so let's change it to C, it does something else. It won't display the number, but it will convert that number using the ASCII table to its equivalent in the ASCII table. So character F120, and let's run it. Instead, it displays X. So let's check what X is on the ASCII table. 120. So we are checking for character 120. 120. As you can see, 120 is X. Let's display the value for W, and W is 119. So if we change this value to 119 and run it, you see it is W. So that's that on character as a string to display a character and also an integer value using the ASCII table. The next one is the unsigned character. When a character is unsigned, it means you don't want to deal with the negative value. So instead, it adds all the negative to the positive. Then you have double what you have before. So for the signed, all these characters, they have signed before them, but there's no need to put it. There's no need to add the signs to it. So that is why it's just ordinary char. So for the unsigned character, you have 0 to plus 255. But for unsigned, it starts from minus. The sign starts from minus, while the unsigned does not have a negative value. That is just the difference. The same thing is still applicable to both. The next is short. You have the short integer and the unsigned short integer. So let's put that. So people call them short, but you can add the integer. So the short integer h has a value between these, and it stores more numbers using 2 bytes, while the unsigned short integer stores the same amount but double the amount, but this uses the same size in memory. So we have the short integer and the short unsigned short integer. So let's display their value. Unsigned, okay, there's an error, and where is that coming from? So you can also call them short. Why is that? Okay, it's running now. I wonder where the error came from. So now you see we've been able to display the value of our short and long integer, of our signed short integer and unsigned short integer. The next important one, like you all know, is the integer itself. So integer uses a memory size of 4 bytes, and it stores between billions of integers, billions of characters. And the format specifier is format %d, and for the unsigned you use %u. So let's display our integer. You already know about integer, but let's just display it. integer j. So that's it. I don't know why my code is running with an error before it works, but this is it. So you see that we've been able to display the value of our integer, which is here, and also for the unsigned integer, which is also this. The next one you would see is called the long integer. So the long integer can store more than billions of characters. It uses 8 bytes. In short, it stores up to 9 quintillion, and the unsigned stores up to 18 quintillions. So let's see them in action. Run. As you can see, we've been able to display the value of our unsigned long integer and signed long integer. The reason why this u is here is because it throws an error without the u because the values are so long, quintillion. So let me run it and let's see the error. Wow, actually, let me save. So let me run that. And as you can see, there's an error, expected identifier. Let's run that again. So you see, the number or the value for u is so long, so we have to return the u to display it properly. Save, clear, and now it works properly. So it throws an error because the value is so long. But before I close this video, I want you to know that while it is important for you to know about all these data types, you won't be using most of them. The ones you will be using are mostly character, both of these two, characters and array of character, the floats and double, the boolean, and also the integer. Those are the important ones that you would use, and those are the important ones for you to note. So thank you for watching. I'll see you in the next video. So hi guys, we are now in format specifiers. So what has format specifiers? I know you're seeing them already. Format specifiers are used within a printf statement, and they help to define and format a type of data to be displayed. So like you know, if you want to display a character, you use %C. If you want to display a string or array of characters, you use %x, s. If you want to display a float, you use %f, double, integer, and so. Now, let's create an illustration. So imagine we have a float called shoe, and it costs 10.78. So let's create more items, maybe 3 of them. So this should be bag, and let's say this costs 120, and this should be shirt. I love shirts, and this could be 210, but let's make it 138. Yeah, it should be expensive. Now that we have this, let's print this on our screen. So like I said already, format specifiers are used within the printf statement. So obviously we are going to be using a printf statement for this, and they define and format your data or the type of data and the way you want it to be displayed. So let's create the first printf statement. So let's say the shoe costs, okay, the shoe costs, then the amount. So we put the format specifier for float, which is %f, okay. The shoe cost, let's put a semicolon here. So let's put a $sign, it's money. Then now we can call the variable shoe. So let's display that first. So I'm going to run this, I'm going to save, and I would run this now. So as you can see, the shoe costs $10, but then you see a lot of zeros have been added to this. So the first thing we can do to remove all these zeros, we can determine the number of decimal precision that we want for this result. Okay, so just immediately after the percentage sign, you can use dot 2. Let's use dot 2. Let's assume we just want 2 decimal precision. All right, that's dot 2. And as you can see, it has been changed. Now we have our value properly. So we are using 2 decimal places or 2 decimal precision. Okay. Now let's print something for the other guys. So the shoe cost, the bag cost, let's do that for the bag. And let's do this for the shirt. So I'm going to change this to bag so that we can get the value of the variable bag and also the value of the variable shirt. So let me clear this. Now as you can see, we can print all our results and let's see what happens. I have to put a new line character. So let's do that. You see, as we proceed, we learn, and that is the most, or that's the best way to do this. So I want everything to be on one line. On each year they should appear on one line each. So yeah, there we have it. So they are on one line each now. But then, like you know, we are already using the decimal precision. We can also use something called minimal field width. And to do that, you use that in front of the dots or just after the percentage. So let's say we use 8 for that of the shoe. We save. As you can see, there are spaces now in front. So it basically helps you to create spaces. So let's try it for the other guys. Let's put 8 here. And let's put 8 here. So the 8 is for the field width. Take note. Save. And as you can see, we've pushed all our figures forward. I want it to align. So let me add more for the one for bag. So let me say bag should be 10 field width. And let's see. So you see. So let's align that of the shoe. So shoe should be 9. So you can use it to align your figures. So let's align it. So I'm scrolling. So this is it. You see how aligned the figures are now. Also, you can left align. And for you to left align, you use minus just in front of your minimum field width. So for shirts, -9. Let's see what happens. And as you can see, -9 has moved it backward. So that is all for format specifiers. And now you know that you use them inside of a printf statement and they define and format the type of data that you want to be displayed. I'll see you in the next one. So guys, I just want to touch on constant quickly. So a constant is a variable that can be changed or shouldn't be changed. So naturally, this is the value of pi. We know what pi is. So pi is 3.14159. But if I come down here and I say pi is now equal to 560 point, no, just gibberish. Let's see what happens. So let me run the code. As you can see, the value of pi has been changed because pi now takes the second value, not the first one anymore. So you need constants if you want to make your code more secured or you don't want some variables to be changed. So how do we make a variable a constant? And it's simple. We just precede that variable with the keyword called const. And it's also good to make the variable name in capital letter. So let's save that and let's see what our result becomes. So if I run this code, oh sorry, pi. It should be in capital letter now. So let me clear this. So if I run this code now, you see we get the value of pi, right? But what if I now try to change the value of pi now on line 9? As you can see, we have an error That is because it says assignment of read-only variable. So when you make a variable a constant, it becomes read-only. You cannot write to it anymore. So now that it is a constant, it is important that to know that you cannot change it anymore. So you leave it as it is, and let's run our code again, and let's ensure that our constant is behaving properly. So there you have it, and that is constant in C programming language. Thank you guys. I'll see you in the next one. Hi guys, this is Precious, and we are moving steadily. So in this video, we will be talking about user inputs. So let's create the file that we will be using to do that. User inputs. So the idea of this section is for us to be able to collect information from the user and display it on the screen. So let's begin. The reason why I type this every time is so that you can always follow and understand it, or you can get it in your memory. So while I do it every time, you can always see me do it and you can understand why I have to do it. So this is the basic structure of any of your C file or your C program. So we'll return 0. Now let's begin. The first thing we want to do is to set a variable. So let's assume we want to collect the user age. We want to know the user age. We can start with int. So we initialize a variable called age, right? But it's empty right now. Then we proceed. So we use a printf to ask a question. So let's say we want to ask, how old are you, right? So we use a printf to do that. How old are you? Like you know already, this is a question, so it demands an answer. Now this brings us to the big one. So for you to be able to collect information that the user enters, you use scanf. Scanf is like the opposite of printf. You use printf to display results. You use scanf to collect results. So the result we are collecting here is an integer. And the format specifier for an integer is %i or %d. Then the name of the variable. Okay? But we need to do something here. You need to add an ampersand. What this does is that it helps you to trace this variable to its location in the memory. Or let's just call this sign the memory address. So the memory address helps you to store the variable in memory. So it gives you the location of where this variable is stored. In subsequent videos, you would see the memory address in action. And now that we've collected the user inputs, the next thing is for us to also display the result, right? So something like you are format specifier. So we want to say you are 100 years old, something like that. You are. So that's where the variable will be. You are. You get it? The format specifier, you are years old. Then now the variable that would replace the format specifier is age. Okay? So let's save. Now let's run this. As you can see, nothing is displaying, and that is because if you're using VS Code, this terminal only does output. For us to be able to collect inputs and outputs, we have to use terminal. But it won't work now. For it to work, we need to do a setting. But if you're using just terminal alone, compiling from GCC directly, you don't need to do this. But if you're on VS Code, you have to do this. So let's go to settings. And let's search for code runner. So the settings we are looking for is the one that says run in terminal, right? So this is it, run code runner, run in terminal. Then you check it. And now that it is checked, we can go back and rerun this script. So let's run the code. And now you see it's in the terminal and it's asking how old are you? And I would say 100 years. And as you can see, it says you are 100 years old. Let's try it again. Let's rerun the code again. How old are you? I'm going to say 300. Enter. and it says you are 300 years old. Let me clear this. Now, what if you want to also take the name of the person, not just the age? So we want to do something like, hey, Precious, how are you? You are so years old. So the first thing we need to do is to set the variable for the string. So if you realize, my name is not just a character. It's not like A, B, C, D, one character. It's a string. So you have Precious. That makes up my name. So that means you have to set that inside of an array. So you say char or character, then name, then ensure you put this brackets, okay? Then you close it. So you use the square brackets to declare an array. Then inside of it, you have to set the size of the array. So you have to set the numbers of characters or bytes that you can use inside of the array. So let's set this to 40. So we want to use 40 bytes in this array. And now, how do we collect information for this array? You start your printf again. So let's ask for the person's name. So what is your name, all right? Printf, what is your name? Then we have to use scanf to collect the information that has been entered. So you say scanf, then the format specifier for string is an S, %S, then you collect the name. Take note, for string, you don't use the memory address, you don't need it. But you need it for integer. So for string, we're not going to use the AND. Take note of the difference, please. For string, no AND, but for integer, there is an AND. And also for single characters, there is an AND. So let's continue. And now, let's display the result for the name, isn't it? So we have printf. Let's say, how are you? Then the name. So call the format specifier here S string. How are you? Precious, welcome. So let's do something like, how are you, Precious? Welcome. So the variable is name. So let me put this right up here, just before the age printout. So let me explain what we've done here before I run the script. We first declare an integer, a variable called age. We also declared a variable called name that will collect an array of characters. Then we will be asking, what is your name? Then we are going to collect the information entered by the user. Then we also proceed to ask, how old are you? Then we also collect the information entered by the user. Also, for string, we don't need the memory address, but for integer, we need the memory address. Now we are printing both results. How are you? So the name will be replaced here. Then the variable that will collect the name to replace it here. Then also we did printf for the age. You are %d years old. Then this age will replace this. So let's try this. Let's run this in the code. I just saved. So run. So what is your name? My name is Precious. Enter. How old are you? I'm 300 years old. So you see, it says, how are you, Precious? Welcome. You are 300 years old. Let me put a new line character so that we can see this properly. Then let me clear this terminal again. So let's rerun the code. What is your name? My name is Precious. How old are you? I'm 400 years old. So you see, it says, how are you, Precious? Welcome. What we have here. Then the next one goes ahead to say, you are 400 years old. But what if I want to enter my full name? So let me do that. Let me clear the terminal and let me enter my full name. So I'm going to say my name is Precious. Take note of the space now. Okay, now you can see what has happened. Our script can't continue. Instead, it just outputs the result immediately. How are you, Precious, without my second name or my last name, sorry. So the problem is scanf can only walk till the next white space. If it meets a white space, it's going to stop. So if we have something like hello Greek as the input, scanf will only collect hello only, and it will ignore this guy and it will kill the script. So for you to be able to use scanf and use space, you have to use another function called fgets. Okay? So fgets will make fgets is like scanf, but fget makes it easy for us to work with what's it called? String characters. So let me comment this out and let's use fget. So fgets is going to take in 3 arguments. The first one is the variable, which is name. Remember, our variable name is name. Then the second one is the character count or the bytes or size that you want. So let's make it the same. Let's say 40. Then the next one is standard input. So this is what is going to collect the input for us. Okay. Now let's do this. So now I will be able to use my full name and we won't have this problem anymore. So I've saved this and let me run it with, I won't clear the terminal so that you can compare the results. Okay. So let me run this now. What is your name? Precious. Now there's a space in between, as you can see. How old are you? I'm going to use 500 this time. And now you see, how are you, Precious? Welcome. But there's a problem with using fgets. Okay? Fget is going to push the next line after your input into a new line. So for us to correct this is a bit advanced, so you may not need to watch this anymore, but let me just do it because we are still going to practice this in when we get to string functions. So to correct this issue here where the other output goes to the new line, we have to use a function called string length. So to correct the problem, all we do is just say name, the variable, then we get the length of the string. So strlen means string length, okay? Like the length of the string. So we want to get the length of the string name. So when we get the length, minus 1 from it, okay? When you get the length, minus 1 from it. And when you minus 1, make it equal to %0. So there should be no new line there anymore. That is what it means. So let's rerun this and let's see if it works. If welcome is going to be in front of Precious. Oh, sorry, there's an error there. Not percentage, sorry, slash. So let me clear this. It still wants to run. Okay, so now let's do it now. So run, I'm going to save this, then I would run it again. strlen, of course. Oh, sorry. So for us to use the function, we have to call in the string header, okay? Take note of the header. So include string dot h, okay? We have to call in the string header. That is why we are having that complaint there, because it can't find the header. So now that we've called in the string header, we can now use the string function, okay? So we're a bit ahead, but it's okay. So I'm going to clear this again. Let's rerun the script. Where is that? Okay. Okay, now let's go. What is your name? Precious. Iriaevho. Enter. How old are you? 400. And now you see it says, how are you, precious Iriaevho? Welcome, you are 400 years old. Don't worry if you don't understand why I use this here and the string header. In the next video, in a couple of videos, we're going to see the string functions in action. But for now, please practice on how you can output characters and integers and strings. Okay? I'll see you in the next video. Thank you. Hey guys, welcome to operators. In operators, the very first one we'll be talking about is the arithmetic operators. You may have come across this before, but let's talk about them again. So in arithmetic operators, the first one we have is addition, subtraction, multiplication, division, modulus, which is the remainder of a division, increment, which does an increment by 1, and decrement, which does a decrement by 1. So let's see it. Let's do the addition. So first, let's set some variables. Let's say variable x is equal to 5. Variable y is equal to 2. Then let's print the result. Print f. And this is an integer. So we use the format specifier for integer. And yes, let's call this z. But before then, we have to do the arithmetic. So let's just do this. Let's call this result is. So for the first arithmetic operator, we use integer. We do 5x plus y. All right. So z is equal to x plus y. So let's see the result of that. Obviously, you should know that. So result is 7, right? Now, what if we change that to a minus? Okay. X minus y. Oh, sorry. I did not save that actually. That was why. So let me clear this. Now let's do that again. So you see 5 minus 3. 5 minus 2 is 3, all right? Now, let's proceed to multiplication. So I'm going to comment that out, and I'm going to use the multiplication symbol. Then let's run that again. So let's see the value of z now. And now, z is 10, that is 5 times 2 is 10. So let's do a division. That's 5 divided by 2. Let me clear the terminal, sorry, the output. Then save, and as you can see, it says result is 2, but you and I know that 5 divided by 2 is not 2. So the problem here right now is the fact that we have to store our answer as a float. All right, so because you are dividing two integer, it is not going to get the decimal value. It's going to truncate it. So what is happening here is called truncation. So to prevent it from being truncated, we have to set the new format specifier for our answer to be a float. All right. But then I want you to see what happens now. So now that we collect the result as a float, we also need to cast the divisor also as a float. So this is called casting. So we are now going to cast this integer. Previously, it's an integer here, but we're going to cast it as a float right here, okay? So to cast an integer as a float, you do this. So this is called casting. So we just casted y. Previously, y was an integer 2, but now y has become a float 2.0, all right? So let's do that, then change the format specifier here to a float. And let's see if we get the right result now. So let me clear the terminal again. And let's do that. And there you have it. We have our result 2.5. So now you see 5 divided by 2 is actually going to give you 2.5 because there is a remainder. All right. Now let's go to the modulus. So I told you previously that modulus gives you the remainder of a division. So let's see that in action. So we have int z is equal to x modulus, that is the symbol for modulus, modulus 2 y. Okay, so let's see what the result is. So modulus gives us the remainder of the division. Let's clear the output and let's get that on the screen. So let's run this. And as you can see, it says the result is 1. I have to change back the format specifier to an integer. That's why we had the wrong result there. So clear output and let's do that again. And as you can see, the result is 1. That is, when x divided by y, that is 5 divided by 2, the remainder is 1. That is the modulus. Remainder of a division is the modulus. The next one is increment. So in increment, what we can do is we can increment a value by 1. And let's see that in action. So let's say we want to increment x. X is currently 5. We say x plus plus. Okay? So just for you to understand, x plus plus means x is equal to x plus 1. Alright? So let me run the results and let's see what we get. So I'm going to turn this to x. And now let's see what we have on our screen. So previously x here is 5, but now we've done an increment to the value of x, okay, using x plus plus, and now let's see what it turns out to be. So let's run that, and x should be 6 now. So you see x is currently 6. That is to say x plus plus, that is x is equals to x plus 1, and that is why we have 6 right here. Now let's do that for the value of y. So for y, we could now do decrement for y. So y decrement 1 is the same thing as saying y is equals to y minus 1. Okay, let's turn the results back to y so that we can get our value on the screen, and let's run this. So I'm going to comment out the increment for x, and let's see. So y should become 1 now. From 2, y should be decremented to 1. And there you have it, y is currently 1. So guys, that is it on arithmetic operators. I believe you're getting fully grounded and interested in C programming. And while we continue, I hope you get your hands busy. I'll see you in the next video. Thank you. Hi guys, welcome to this video on augmented operators or augmented assignment operators. So if you remember in the last video, we could do this. We told you if you have x is equal to x plus 1, you can actually do it like this, x plus plus. But that's when you're incrementing by a value of 1. What if you're incrementing by a value of 2? So maybe you want x plus 2. There is nothing like x plus plus plus. So this brings us to the augmented assignment operators that makes it easy for you to do this. So what are augmented assignment operators? They are used to replace a statement where an operator takes a variable as one of its arguments and then assigns the result back to the same variable. So where we had x is equals to x plus 1 from the last video, and we could do it as x plus plus, we can also do it as x plus is equal to 1. As you can see, the three of them are the same thing. The first one is your normal assignment operator. The second one is your incrementer by 1. And the third one is the augmented assignment operator that we are dealing with in this video. So let's proceed. So now, if we want to add 2 to 10 to x, we could do it like this. X is equals to x plus 2. But then using the augmented operator, we could actually do it like this. X plus is equals to 2 because it means x is equal to x plus 2. And let's print the result and let's see what we have on the output. So there you have it, 12. So that means 10 plus 2. So x is equals to x plus 2, and that is 12. Same thing when you have your subtraction. 10 minus 3. But instead of doing it like this, you can actually do it like this, okay? Using augmented operators. And let's see if the result is 7. And there you have it, 7. So, same thing, x is equals to x times 4. We can actually write it this way. Instead of writing it like this, you can do it like this. And let's see, and that should be 40. Oh, sorry, I did not save that. Sorry, guys. Let me clear the output. So there you have it, that is 40. So if we go ahead also for division, same thing applies or is applicable when you divide. So instead of saying x is equals to x divided by 5, you can use the augmented operator for division and say x divided is equal to 5. And let's see what that comes out to be. So I save, then I run, I see you have it as 2. Remember the problem I told you from before, we have to turn this to a float. But you know, that is not the scope of this video. I just want you to see that you can use augmented operators. And also for modulus, you can do the same thing. So modulus is the remainder of a division. And when we do that, it still works the same way. So you see, the modulus is 0. So when 10 is divided by 2, this division is actually a proper one. There is no remainder, so you have 0. So guys, that is it on this video on augmented operators. I'll see you in the next one. Hi guys, and Precious here again. In this video, we'll be talking about logical operators. Logical operators are used to check if two or more conditions are true. Basically, logical operators helps you to test between two or more conditions, okay? So when you have something or you have some conditions you want to check, it makes it very easy for you to make your changes, okay? So now, for logical operators, the first one you need to note is called the AND operator. The AND operator checks if two or more conditions are true. It only comes out verifiable if two or more of the conditions are true. If any one of the conditions fails the test, then it doesn't perform. So let's do a quick script here. So let's say int x is equals to 25, okay? Then let's create another variable called let's make that a character. So let's say character name is equal to not name, let's just use a single character. So let's say a character alpha, yeah, from alphabet is equal to b, okay? So let's do a quick if statement. So don't bother about the if you don't understand it. What I want you to know about this is the fact that we want to check the condition. So ignore the if and just focus on the condition. In subsequent videos, I'll be talking about the if statement. So to test if the conditions are true, we have to create our first condition. And the first condition will be something like, let's say s is less than 40. You can see that this first condition is true because x here is 25, and now we are telling the if statement to check if x is less than 40. Yes, so x is less than 40. Then let's say we want to add another condition. That is when you use the AND, okay? You use this symbol, double ampersand, to check, to do that. So now let's say we want to check alpha too. Alpha. So what is alpha equivalent to? Alpha is equivalent to b, okay? So let's print out something if it is true. So let's say print f, okay? Then we say the AND condition is true. And what if it is not true? Let's print something out. So let's say else. Let's just say something simple, something like condition failed. Okay, condition failed. So this is a very basic script. All it does is just to check if our conditions meet the requirements. So without testing it, we can already tell that our conditions will be true. Why? Because the first one here says x is lesser than 40, and if you check here, the variable s is actually 25, which is less than 40, and the next one says alpha is equivalent to b, and if you check it, that is true because alpha here has been set as to the value of b. So let's run this script to see if we are correct. And as you can see, it says the AND condition is true. But what if one of the condition fails? Let's say we now go ahead to say x is greater than 40, which is not true, by the way. X is not greater than 40. Let's see what happens. And it says the condition has failed. So you see, for the AND condition to come out true, all conditions must be true. Now let's verify. Let's add another variable. So let's add something like let's say, let's call this let's add another alphabet, or let's do a new condition. Let's add a boolean. Okay, so let's say bool sunny. Okay, and we can set this to true. But for you to use boolean, you have to call in the header for boolean, include std bool.h. That is only when we can use the boolean. Okay, now that we've set a new variable, let's also check if that is true. So we can see we can use more than two and. That is why I'm trying to do this. So let's say sunny. Sunny has been set to true. Okay, sunny has been set to true. And let's return this variable back to lesser than. So now we have three conditions that are true. X is less than 40. It is true. Alpha is equivalent to b. It is true. Sunny is true. It's true. So let's see what it prints out on our terminal. You see, the AND condition is true. That is because everything here is true. Also, I want you to see something. When you are using boolean, true can also be equal to 1. Okay, let's do that and see. And as you can see, the condition is still true. And also, you can also use the variable name alone, sunny. That means it is true. So let's do that again. And as you can see, the condition is true. And that is it on the AND state, the AND condition, the logical operator. All conditions must be true for AND to come out true. Okay, now the next one is the OR. So let's go to OR, but we still leave our variables the way they are. So I'm going to copy it down for OR. Now when you come to OR checks if at least one or two of the conditions are true. That is, if at least one of the conditions are if one of the conditions are true, then it ascertains to be true. So let's see that. Now we have x is lesser than 40. Let's make that greater than, which is false. And alpha, let's say alpha is equivalent to c, which is not true. So now we have two conditions that are true, that are false, but we are still using the AND operator, so we have to change it to OR. For OR, you use the double pipe. Okay, so you use double pipe for OR. So if x is greater than 40, which is false, s is not greater than 40, or alpha is equivalent to c, which is false, alpha is not equivalent to c, it is b, and this is sunny. So let's make this one true. This is the only one that is true. Sunny is equal to, sunny, it is true. Or let me just make it easy for us to understand. So let me put it here, true. True. This is the only one that is true. Okay, but let's see what happens if the whole condition is going to ascertain to be true. So let's run this. And as you see, it says the whole condition is true. Now look at it again. this first one is false. X is not greater than 40. It's actually lesser than 40, which is false. Alpha is not equivalent to C. It is B, which is false. But Sunny is the only one that is true, because Sunny is true. And yet the old condition ascertains to be true. So when you need to look at it like this, just observe it and say it to yourself that when you use or, you want to know if any one of the condition is true. If any of the condition is true, then everything is true. But for and, all the conditions have to be true, like we've shown previously. Okay, so one last time, let me run this again. And what if I change Sunny to be false? So Sunny now has become false. Let me make Sunny to be false. And let me make alpha to be true. The only one that is true now is alpha, which is B. So X is not greater than 40. That is a lie. It is false. S is equal to 25, which is lesser than 40, not greater than. And Sunny is true. But here in our condition, we say Sunny is false. The only true condition here is alpha is equivalent to B. And yet, this is going to ascertain to be true because one of the condition is true. So let's run this again. The or condition is true. Okay, now the last but not the least is the one known as not. So the not operator is used to reverse the state of a condition. So let's try that. So remember from above, we use the boolean. Like I told you, if you want to use the boolean, you have to bring in this header, include std bool. Okay, so let's create a small condition based on this Sunny. So let's say if Sunny is true, which is true by the way, we say something like printf it is sunny today, then an else printf it is cloudy. So if we run this, it is going to be sunny because the condition is true, right? Let's do it. So you see it is sunny today because it is true and our condition is checking if it's true. But what if we invert? So before I go there, I want you to, like I told you before, you can also write this as if true is equivalent to 1. So true is also 1. So let's do that. As you can see, it's still sunny today. And what if there's another third way to write it? You can say if sunny. So this is also true if sunny. So let's save this and let's do it. So you see, it is still sunny today. Now, what if we want to use the not operator to change it? So to reverse the state of this condition, all you do is you use the exclamation mark before the variable. So if I put the exclamation mark here, if it's not sunny, what should it print out? Yeah, I hope you guessed that right. So you see, it is cloudy. So if it is not sunny, this is no longer true. It prints it is cloudy. So instead of turning it, let's just switch it around, okay? So if it is not sunny, it should be cloudy, okay? Cloudy and sunny. So let's print that out. So if it is not sunny, it means it is sunny. That's wrong English. So if it is true, if it is false, they can switch that to it is cloudy today. So basically what this does is it inverts what is coming. So if sunny is false here, it makes it true. And if sunny is true, it makes it false. So that is it, guys, on the AND operator that only comes out true if all the conditions are true, and OR operator that comes out true if at least one of the conditions are true, and the NOT operator that is used to reverse the state of a condition. So that is it, guys. I'll see you in the next video. Hi guys, so before we proceed to the if and else or the conditional statements, I want us to just be aware of some math functions that you would find in your programming journey in C. So before you can use the math functions, you have to call in the variable called include math th. Okay, so that's the math header. So let's begin. The first one here is called rounding up. So integer a, round this number up. So let's call that up on the output. Let's see what it comes up with. So we are rounding, let me make this 7. We're rounding 7.146. Let's see what it comes out to be. And there you have it. It has been rounded up to an integer 7 from this. So let's also try seal. So seal is when you round up a number. So let's round up 4.146. Let's round it up and let's see what it comes out to be. So 4.146. Let's seal it, not round. We're sealing up. So when you say when you seal, you are rounding up. So it goes up. So you see it's 5. From 4.146, you now have 5. That is round up. The next one is floor, which is rounding down. So let's round down 3.99. Let's output that. As you can see, we've rounded down to 3 from 3.99. The next one is square root. So to get the square root of a number, you use the sqrt function. So let's do that. Let's get the square root of 9. Oh, sorry, not 9. D. Variable D. So square root of 9. And there you have it. Oh, you have to use the right specifier for double because we are using double. So that will be LF. And let me clear the terminal and do that again. So let's run this. And there you have it, 3.00. That's 3. So let's try the one for 81. Let's see what we get. Square root of 81. So this comes in handy if you want to build up a calculator. So this is 9. Let's clear that. Also, you have the power. So when you want to raise 2 to the power of 4, you use power or POW. And let's try that. So 2 to the power of 4, that's 2 times 2 times 2 times 2. 2 times 2 times, times 2 times 2 times 2. So let's, that is E. So let's output that. And that is 16. Okay? Then also the absolute value. So if you want to get the absolute value, that is, you put in a negative value and it shows you the distance of that number from 0. That is absolute. Let's see what that comes out to be. So absolute value of minus 100, obviously, that will be 100. That is, we are minus 100 away from 0. That's absolute value. Also, you have logarithm. So you have log 3. So what is log 3? Let's see what that is. G. Let me clear the terminal. So log G, we give you log 3, we give you what? 1.098. Also, if you know anything about trigonometry in mathematics, you know about sine, cos, and tan. So let's do that. Let's do sine 45. Sine 45, that is variable h. This is sine 45. Let's also do cos 45, variable I, cos 45, and that is 0.5253. And the last but not the least, let's do tan 45, and that is J. That is 1.619. So there are so many other math functions, but these are like the popular ones you will tend to use a lot of time, and that is why I had to talk about them here. So guys, I'll see you in the next video. Thank you. Hi guys. So welcome to if and else statement. If and else statement is used to test conditionals. So assuming you have a program where you want to check if different conditions are true, you use the if and else statement to ensure that it is working properly. So let's do it instead of talking about it. So include, I'm going to bring in my header first, my standard input header, stdio header. Then we create the function, include is spelled wrong. So we create the function int main then we return 0. That is, the program is successful. So let's assume that we have been tasked to create a script or a program for a betting website that allows users to register based on their age. So naturally, betting sites, we allow people who are from 18 years old and upward to register, okay? So this is a betting website program. We've been paid a lot of money to do this. For us to test if someone can register, we have to create a way whereby we can tell them to tell us their age, and we would run some conditionals using if and else with that. Okay, so remember, printf to tell them to tell us their age. So what is your age? So now that we have asked them for their age, we need to be able to allow them to enter the age. So you use the format specifier for integer because it's an integer value, all right? And the memory address of age. But as you can see, there's a problem because we have not initialized the age variable, which you should always do first. So now that we have everything set to receive user inputs, okay, the next thing is to create our first if statement. So if, and what do? We want to allow those who are 18 years and upwards to be able to register. So what do we do with that? We say if age is greater than or equal to 18, okay? Remember when we talked about augmented conditionals, we had different types: equivalent to, lesser than, greater than. You can use any one. In this particular condition, we'll be using greater than or equal to 18, and we should tell them that congratulations, you can register, right? So let's check this in action. So first you have to go to, if you're using VS Code, you have to go to your settings, then type code runner to ensure that you can run in terminal. Then you come back and let's do this. So let's run this. So what is your age? I'm going to put an age greater than 18. So I'll say 20. And as you can see, congratulations, you can register. What if I enter an age lesser than 18? 12. Nothing happens because, like you guessed, we can use an else statement. So I will say else. So else is everything that will happen if this condition did not meet. So else, just tell them something like, sorry, you cannot register. Okay? So now we have a condition for those that are not above 18 or equal to 18. So let's try it out. Oh, sorry, printf. So let's run it again. So let's say 13 years. And it says here, sorry, you cannot register. But then this script is still very basic. What if we have someone who is lesser than 18? We need to give them a message that is properly, unique to them. Instead of just saying you cannot register, let's tell them why they can't register. So we can use a new if statement that is called else if. So you use it after the if and before the else. It's called else if, then you put in the conditional. So in this one, we want to talk to people who are above 0 years old but less than 18 years. Okay? So we'll say age. If age is greater than or equal to 0, that is people from 0 years old upward, and remember, both condition has to be true, and age is less than 18 years old. What do we want to tell these guys? We want to tell them that, sorry, you are too young to bet. So let's try that. Let me clear the terminal. So I will enter an age lesser than 18. Let's say 15. And as you can see,
you are too young to bet. All right, so that is else if in action. So we've said if age is greater than or equal to 18, tell them congratulations that they can register. But if their age is greater than or equal to 0 and it is less than 18, we tell them that they are too young to bet. Okay, so let's add a little bit of fun to it. So what if we have someone else who enters a wrong age, maybe something like something lesser than 0. So let's say if age is lesser than 0, that is -0, -1, -2, -3, okay, we have to tell them something, because there's some people like that, they will just want to play with the program. So we tell them, sorry, you are not human, or do not exist. So you see, I'm just trying to show you that you can use as many as you like, so many else if in between the if and else statements. You can use 100 else ifs, but then you will see why it becomes tasking if you have a lot of else if. So let's test this one that we just put in. Sorry, print F. Why do I always say print? So print F. Let me clear this terminal. So much errors. Good. So let's say the age now is -20. You see, it says, sorry, you are not human or do not exist. So guys, that is basically it. We just created a simple betting websites program that takes in the age of the user and checks if they are above 18, and it allows them to register. If they are lesser than 18, it doesn't allow them to register, and it tells them why they cannot register. They are too young. And if they are lesser than 0, it tells them that they are not human or do not exist. Or if they enter some other wrong input, it tells them, sorry, you cannot register. Okay, so this is your if and else statements in action. And take note, you can use as many else if as you want in between the if and the else statements. So I'll see you in the next one. Hey guys, welcome. In the last video, we touched on if, else if, and else statement. But then, like you must have noticed, there's a possibility that you can have so many else if statements, and it's bad practice to have so much else if statements. So instead of that, we can use a switch statement. So a switch is a more efficient alternative to using many else if statements, and it allows a value to be tested for equality against many cases. So let's put this in action. Let's assume that we want to create a grade script or a grade program that prints out a message depending on your letter grade. So from school, you know, we have A, B, C, D, and F, which is failed, by the way. So let's get to it. So let's create a variable called grade, initialize it, then let's use a printf to collect the user input. So when the person inputs, we'll ask the person, please enter a letter grade, then it will tell you what your score is or what your grade is. Please enter a letter grade, and we will use a scanf to collect that. So scanf format specifier for a character is C, and what are we taking? We are taking grade using the memory address. Grade. This ampersand here stands for memory address. And now that we have our inputs, let's now test our cases using a switch. So this is how you write a switch statement. Since we are testing with grade, so we call grade in here, then open the bracket, then we start. First, we use cases. So we use case. The first case will be case A. So if the person enters A or he scores A, you use a colon, Then what are we printing? We print out a message. Printf. Wow, you scored an A. Then we break out of it. Okay, so you see, it's easy. You can just copy it and start pasting so that you can, instead of typing it all. So we want to have A, B. Sorry guys. Okay, so I'll make this B. Wow, you scored a B. Wow, you scored a C. I'm just going to make it generic, you know. C. I think we are going to F, so let me just copy these 3 at a time. Okay, A, B, C, D. What's the point in typing if we can copy, right? Let's just do that too. D, E. Just take note of the way it is arranged because it is important. F. And last but not the least, we need a default. So default, all these cases are like else if, else if, else if, else if, else if. Then the last one, which is a default, is the else. So we tell the person, please enter a valid grade letter. Okay guys, so let's run through it again. So what we did is we created a variable grade, and when we tell the user to please enter a letter grade, we collect the input using the scanf with the character specifier and the variable grade from the memory address. Then we now try to test it using the switch statement. So we are testing grade, the variable grade, and the first case is if the letter is A, it should print wow, you scored an A. If it's B, same thing, down to if you input F, wow, you scored an F. And if it is anything different from any of this character, it should output enter a valid grade. So let's put this to test. Let's run this, guys. So here it is. Please enter a grade, and I'm going to enter A. And you see it says you scored an A. Let's run it again, but let me just put a semicolon here so that, yeah. So let's run this again. Please enter a letter grade, right? I'm going to enter D, this one, D. And as you can see, wow, you scored a letter D. What if I enter something that is not here? Let's run it. Maybe something like Z. And as you can see, it goes to the default and it says enter a valid grade letter. Now, you may be wondering why we're using the break. There's only one way to know why, is by taking it out. So I'll take out all the break and you will see why we are using break in this statement. So delete break, delete break. I'm taking out all the break, so there's no more break. Now, let's rerun this script. Enter a letter grade. I'm going to enter C. Then you'll see what will happen. C. As you can see, all our grades after C have been printed out. Wow, you scored letter C. Wow, you scored letter D, you scored D, you see? So, what the break does is, once a case has been achieved, after the message or the statement has been done, break helps you break out of the switch. So, if you don't have break, your script will keep running. So, let me Ctrl Z to bring back our breaks. Save. And I'm going to run this again. So, let's see the difference when we enter letter C without break and enter letter C with break. So C with break now. And as you can see, wow, you scored letter C. After it does the printf for this, it breaks out of the switch statement. So guys, that is it on switch statement. As you can see, switch is better than else if, because if it was an else if statement, you are going to be typing a lot of else if. So guys, that is it on this one. I'll see you in the next one. Thank you. Precious out. Hey guys, welcome. I believe you've been having fun in this journey with me. Now we are in the looping section, and the very first loop we'll be talking about is called the for loop. So let's get to it. So basically, your for loop, sorry, let me put my standard input. This is to receive your input and outputs in your program. So don't forget your return. Yeah, so let's go back to it. So your for loop repeats a section of a code for a limited number of time. Okay, repeats a section of a code for a limited number of times, or you could call it repetition. So let's write the code out. To create a for loop, you use the keyword for. You open a bracket, then you set your initialization or your variable. Okay, so we say int index is equal to 1, but most people like to use I instead of index, and we can understand because it's easier to type, so let's use I. So this is called the initialization. Integer I is equals to 1, that is 1 begins from here. Then you put a semicolon. After the semicolon, then you set your condition. So what is the condition we want? Let's say we want I to be lesser than or equal to 20. After that, after your condition, then you set what is called the increment. Okay, so for the increment, we can say I is equal to I plus 1. But remember, instead of writing this long, we can just say I plus plus. Now, this is called the repetition. So anything that you put inside of these coily braces or coily brackets is going to be it's going to be repeated as long as this condition is being met, and this increments for every circle it will be incremented. So let's try something. Let me print F, and let's say Precious Iriaevho is a tutor at Clickate Academy. That's a very long one. So let's see what happens if we run this code, right? So I'm going to run this now. So let's put a new line character. so that we have each statement on a new line. Okay, so I'm going to clear the terminal, then I will do this again. So this is for new line. So every printf statement is going to be on a new line. So let's do it again. And there you have it. You see, Precious Iriaevho is a tutor at Clickate Academy, and this has been repeated as long as I is less than or equal to 20. Okay, now let me take that out. So instead of putting all this, let's print out the numbers that we get inside of this. So let's use our format specifier. Let's just say number. Since it's an integer, okay, then we are printing I. So let me clear the terminal. Let's do this. So we see all the numbers that have been printed out. I forgot the new line character again. Okay, done that. Let's repeat this again. Run. So as you can see, we have number 1, number 2, number 3, number 4 till 20. Practically, we've just counted from 1 to 20. You see, for loop in action. So instead of you writing printf 20 times, you use the for loop to actually do that. Now also, you can increment by 2, and that is, instead of saying I is equals to I plus 2, remember, you can just do this, I plus equal to 2. Let's save that. So we will increment in 2s now, okay, in 2s. So let me clear this, and let's run this. As you can see, 1 plus 2, 3, 5, 7. You get the point, right? So let me put this in 3. Let's increment by 3. And same thing would happen. So you see, it's incremented by in 3s. 1, 4, 7, 10, 10 plus 3, 13, 13 plus 3, 16, 16 plus 3, 19. And, you know, it can't print 20 because it goes beyond it. Now also, you can decrement. And if you want to decrement, it's still the same thing. We say I minus minus, but this time we have to change our condition. So int can actually be 20, and we say when it is greater than or equal to 1, okay, that's when it should stop. So let's print this. So you can see we've decremented by 1. So we started from number 20 down to 1. We can decrement in 2s like we did with the addition. Let me clear this. So you see, decremented in 2s, number 20, 18, 16, till 3. And we can do it in 3s too. So you see, your for loop helps you to, it prevents you from typing so many lines of code. Instead, you can just use your iterations. You can use your loop to print out so many printf statements. Instead of doing it multiple times, you can just have one printf statement doing the same thing over and over again. So that's it in 3s, and that is that for loop. I'll see you in the next one. Thank you guys. Hello everyone. In the last video we talked about for loop, and now we will be discussing about the other type of loop called the while loop. Now, while loop repeats a section of a code, possibly unlimited times. So the difference between the for loop and the while loop is you can use the for loop if you don't know how many times you want to run the code. Like if you want to keep running your code unlimited times, then while loop is what you should use. But if you know how many times you want to run that code, then you use for loop. So you see, while some conditions remain true, that is the only time the while loop will run. If the conditions are not true, it's not going to run. And also, like it says here, while some conditions remain true, a while loop might not even execute at all. That is, if the condition is not met, the while loop may not even run. And we are going to see that in action. So let's replicate the same loop we did for the for loop. Let's replicate it using a while loop. So to write a while loop, first you set you set your variable, okay? So we want to use an integer. Let's call it I. So we've initialized it. Then now you write the keyword for the while loop, which is while, then open bracket, then curly brackets. Now let's begin. So what do we want to do with this while loop? Let's assume we want to print out numbers from 1 to 20. So let's go. We say I should be less than or equal to 20. So this is for the conditional. So while this I, okay, while this I is less than equal to 20, what do you want to do? This is what we want to do. We want to print all the numbers, okay? So we say number, format specifier for integer. Then what are we printing? The variable I, okay? If I run this script like this, there will be a problem. You know why? Because let's do it. Let's see what happens. You know, sometimes it's just better to run it than talking. So I'm going to run this code. So you see what has happened? The code is running unlimited. Zero number, number, zero, number, zero, number, zero. So I have to pull out, because what has happened now is our code is just running repeatedly. Let me put, sorry, I forgot to put okay. So let me stop the code from running. So that's the problem. If you run this script wrongly, you're going to get an infinite loop. It's called an infinite loop. You don't want an infinite loop. So I'm trying to get my computer out of the infinite loop now. Okay. All right, so guys, bear with me. So if your computer system has a very low memory, you're going to have problem with this guy, because your loop is going to run infinitely. Okay, so I'm trying to stop mine now. So for you to prevent that, you have to set an increment, okay, just like what we did in the for loop. So the increment is what is going to prevent it from running infinitely. So I can run it again, and as you can see, it has performed correctly. So let me put in the new line. So if you, let me clear this. So you see, our loop has run correctly now from 0 to 20. If I don't want this 0, I can set I to be equal to 1 here. And we rerun it. And now it starts from number 1 to 20. So let me risk it again. I want you to see the importance of putting the increment. So let me remove the increment again. Let's run into trouble. If your computer is slow or does not have a good memory space, please don't do this, because it's going to freeze your system. Okay, so watch what happens. I've removed the increment and I'm going to run our loop, but it's going to run infinitely. So let's go again. See, number 1 is infinite. It's infinite. It keeps running. It's running infinitely. So I have to stop it now. I have stopped it now. Okay, so always ensure that you have your increment set to prevent an infinite loop. That is one of the problems with the while loop. If not, you will run into issues. Okay, so there you have it again. So with the while loop, you can print anything. And as you can see, I've been able to replicate what we had in the for loop with the while loop. So that's that on the while loop. I see you in the next one. So guys, in last video, we talked about while loop. Now, there is a third type of loop called the do while loop. The do while loop will always execute a block of code once, then check for the condition. That is, when you use a do while loop, it is always going to run the first time before it checks for the condition. So if you remember this program from our last while loop program, you will see that it's the same script. But how do you turn this to a do while loop? It's simple. All you do is just you move the while loop, the while condition from the top, and you move it down here. You close it, then you type a do just before this curly bracket here. And now our program has been changed from a while loop to a do while loop. And now let's run this to see. So I just ran it. We set I is equals to 1, and that is it here. And it ran to 20 because we said while I is less than or equal to 20. Now let's test what happens if we make this condition false. So let's say I is greater than 20. We know I is not greater than 20. I is less than 20 because I is 1. So let's see what happens if we do that. And as you can see, only number 1 is shown from this statement here. So printf has printed the value of number 1, but when it got to the condition, it realizes that the condition is not true, so the script stops running. So you see, it has proven to us now that the do while loop will always execute a block of code once, then it will now check for the condition before it can continue. So that is just the difference between a while loop and a do while loop, and you've just seen a do while loop in action. So guys, I'll see you in the next video. Hey guys, welcome to this video. In this video, we'll be talking about nested loop. So nested loop is basically a loop inside of another loop, and it is majorly used with the for loop or the while loop. But like you know, the most popular one will always be the for loop. So let's create a quick nested loop so that we can see how it works. So for a nested loop, let's work with two variables, int I and j. So we are declaring two variables at the same time. Now, for the first outer loop, let's create a for loop for the outer loop. Okay, so let me create a comment here. Let me call this outer loop, or let me do that in front. So let's say for. So remember, we are starting at 1. Then let's set the conditional. So as long as I is less than or equal to 3, okay, then we can do the increment. So let's do a printf that just tells us that this is the outer loop. So let's know where we are. So let's do a printf here, and let's say this is the outer loop. Yeah, let's put the number. So this is the outer loop, 1 or 2. So this is integer, then the variable name. Okay, now let's create the inner loop. You get it round? So now that we've done the outer loop, so for each iteration, one iteration of the outer loop, all the iteration of the inner loop will be done. So let's create another loop inside, and now we will use j for that. We'll say j is equal to 1, then j is, let's use 3 or 4. J is less than or equal to 4, then j plus plus. And for this, let's print out, this is the, let me just copy this. So this is the inner loop. We'll call this one the inner loop. Don't worry, you'll see what happens now. So this is the inner loop, and the variable is j. Let's put a new line character, because I know how it will look like now without the new line character. So let's put the new line character. So every printf will be on a new line. Let's put a lot of space so that we can see the difference. Then after that, let's printf. So when this loop finishes running inside, before it goes back, let's do another printing to tell you now that the outer loop is done. So this is the outer loop. Okay, let's say this is the outer loop 1 starting. Yes. So this is the outer loop 1 starting. This is the inner loop 1, outer loop 2, or 1 ending. Don't worry, you will see this is the outer loop 1 ending. So it's going to surround it. Okay, you will see it now. So but before I go, let me show you what I've done here. I created an outer loop, okay, with a printf that tells you that it is starting. Then for every iteration, so if this one iterates 1 time, it will do everything inside here. So one of the things inside here is the for loop. So this for loop is going to be iterated 4 times as long as j is not more than 5. Then when it is done, it will print out the ending of the outer loop, then go back again. So if it prints 1 here, it will go back and do 1, 2, 3, 4 inside the inner loop, then go back again. So without talking too much, let's see it in action. Good. So let me increase my terminal so you will see. So look at what has happened. It says this is the outer loop 1 starting, and then it does the iteration 4 times for the inner loop. This is the inner loop 1, 2, 3, 4. Then this is the outer loop 1 ending. Can you see? 1 loop with its own inner loop. This is the second loop with its own inner loop. So this is the third loop with its own inner loop. And that is it, because right here we said we want it to go 3 times. I is lesser than or equal to 3. So just look at the code and run it on your computer and see how it works. So guys, this is it on nested loop. I'll see you on the next one. Hey guys, welcome again. So in this video we are still talking about our loops, and there is something you can do in loops, and it's called continue and break statements. So when you use a continue statement, continue breaks out of the iteration, so it makes you skip a line of your statement or the code, then it jumps to the next one. While the break statement exits out of the loop, or like you've seen before when we did our switch statement, we've used a break before. So let's see it in practice. So I'm going to do a simple for loop. So let's make it 1. Then let's make our condition. Let's say as long as I is less than or equal to 20. Then let's increment I. And what do we want to do? Let's just print out the numbers, okay? Print F. So we are printing out an integer. So let's put a new line so that everything is on a new line. We are printing I. So let me run this and let's see what happens without the continue or break statement. So as you can see, we have 1 through to 20. What if we want to skip the number 7 and jump to 8? How do we do that? Exactly, we use the continue statement, but we have to use the if statement to check when I is equal to 13, so that 13 or 7, sorry, so that we can continue. So let's jump out of 7. So we won't have 7 when we use continue. We'll say if I is equal to 7, what should happen? The loop should continue. Okay? And let's see it in action. We won't have 7. So let me clear the terminal so that it will be visible for us. So let's rerun it. And as you can see, we have 1, 2, 3, 4, 5, 6. But when it got to 7, the loop jumped because of continue. We say if I is equal to 7, continue. So because of that, we don't have 7 anymore. It jumped to 8. So you use continue to skip a line of code or a line or a statement when you are running your for loop. Okay? Now, what if we try to use break? So when I is equal to 7, let's use break instead of continue. Let's see what happens. So let me clear the terminal again, or the output, and let's run this. So you can see what has happened. It counted to 6, but when it got to 7 and it encountered the break statement, it jumped out of the iteration. It jumped out of the for loop, and now we are back to not running any statement anymore. So that's the difference. The continue skips a line of a code or a statement, while the break exits the loop entirely. So guys, I'll see you in the next video. Thank you. Hi guys, I think we should touch on this quickly. So this is binary. This is called bitwise operators. It's a special operator used in bit level programming. They are known as binary, but they come in 8 bits. So you have AND, just like we had before. You have OR, exclusive OR, left shift and right shift. And let's see them in action. So AND is going to be true when two numbers are true. You understand? So when you have 1 here and you have 1 here, it's going to be 1. But when you have 1 here and 0 here, it's going to be 0. So let's just do it before I show you how it works. So let's write it out. So we say Z is equal to X and Y. So let's print out the results. Print F. Okay. Let's say and is equal to, yeah, that should do it. Let's put a new line character. And what variable are we setting? Z. So let's run this. So it says hand is 4, but let's get the value of 4. So let's check it. Let's convert it. So 4
Let me go to my browser. I have this converter here. So if we say 4 in decimal, look at what it gave to us. Let's copy it so that we can go back and confirm. So I'll put it as a comment, 4. So if we check it, x is 6, y is 4, and that's why you have this as the decimal. So if we do 0 and 0 is 0, 1 and 0 is 0, but 1 and 1 is 1, 0 and 1 is 0. You understand? That is how AND work. AND is when two of the values or the integers are true, then it's going to be true. So bit does it, it compares each one by each one. Okay, it stacks them and compares them. Let's try it for OR. So OR is a pipe. So if we do this for OR now, let's see, let's run this. Let's see what OR comes out to be. OR is 14. So let's check the value of 14. I'll put 1 in front of this. Now let's copy it and let's go and reconfirm. Now for OR is true if any of the value is true. So 0 and 0 is 0, right? 1 and 0, 1 or 0 is going to be 1. 1 or 1 is going to be 1. 0 or 1 is still going to be 1. So you see how OR works. Only one value needs to be true for OR to be true. And 0, 0 will always be 0. Now let's try for exclusive OR. So exclusive OR, you will see how it works now. You use the caret for exclusive OR. So I'm trying to find the caret on my own keyboard. Sometimes it just disappears. Okay, with that, let me just copy this so I don't waste time. Let me copy the caret I have here already. Most times it's under before 1. I'm using another keyboard today, so I can't find it on the new keyboard. So Z or Y, and let's see the value. So let me clear our output so that it will be very clear to us. Now Z or Y is equal to 10, right? And what is the value of 10? Let's check it. Then we'll come back and recompare. You see, this is 10. So let's go back and compare our results. Let me put it here. Now, for OR, exclusive OR, you have 0 and 0, 0. 1 or 0 is 1. But for exclusive OR, if two of the values are true, it reverts to 0, okay? It does the opposite of AND. That's why it's called exclusive OR. It only works when you have one of the values to be true. The next one is called left shift. And how do we do the left shift? We do the left shift by using the characters. So let's say something like Z is equal to X left shift 2, okay? So we want to shift the value of X by 2. So let me copy this print and just use it here. Then I will show you how left shift work. Or shift left. So shift left is going to by 2. It's going to move this value of X. This is X. It's going to move X twice here. So it's going to go like this. Let me copy this down here. So this is X currently. So shift left is going to add 2 zeros here and delete 2 zeros here. Okay, let's just confirm it. Let's run it. Let me clear the output. So shift left is 24. So let's convert it and see if it compares to what we have up there. So I'll copy that. and I'll replace this. So as you can see, it's the same with what I have here. You see, it's pretty easy to do without converting. So you see, this is shift left. Then for shift right, let's use the value of y, okay? Let's shift y. Let's shift y to the right. So y to the right. It means that we are going to add two more values, two zeros after here, before. Right? Okay, this is shift right. Capital small letter y. So we add two zeros before rather to shift to the right, 0, 0, and we remove the ones that are previously here. So this is shift right, okay? Now let's do this conversion and see if our values match. So shift left now is 3. Let's convert 3 and see if it matches. So you see, I think it matches. Yes, it does. So see, this is it. So guys, basically it's a very easy one or a straightforward one, but I felt we needed to touch it before we proceed. So guys, this is Bitwise operators. I'll see you in the next video. Hey guys, so welcome to this video. In this video, we'll be talking about memory or memory address in C. So before we talk about memory address, let's know what a memory is. A memory is an array of bytes within a RAM in your computer, which we can signify as the street. Then a memory block is a single unit byte within memory, which is the house, used to hold some value, which is the person. So look at it like this. In your street, which is also the memory, you have a single unit of byte, which is the house. You know, you have houses on streets. And inside every street, you have a person, and that person is the value of the variable. Then, if you want to refer to that house, you use what? The memory address. So the memory address is the address of where in the memory or where a memory block is located. So that is the house address. Let me run it again. In your street, you have streets, right? We have a very long street. Now, inside of every street, you have houses. Those houses in your streets, they are the memory block. Inside of those houses, you have people. Those are the value of your variables. And if you want to refer to a house, you use the address, and that is the memory address. So let's try this out. Let's create some variables, some character variables. A. So let's make this equal to x. Let's duplicate, and let's call this one B, and the next one C, and let's call this Z, and let's call this Y. So now let's print out their sizes. To print out the sizes, we use a printf statement and a size of. Take note. So let's say format specifier of D, because we want to print out a number. Then we say bytes. And what are we printing out? We are printing out the size of each variable. So size of A. So I'll duplicate that. And this is size of variable B. And size of variable C. And let's save that. Let's run this. Sorry, please. So let's put a new line character so that everything comes on one line each. So as you can see, each of these character, they take 1 byte. So let's use this now to describe this. So it means that this person, okay, this person X is stored inside of a memory block A, okay, is stored inside of memory block A in your computer, which is the street. That is just it. But there is something else. Now, let's check for the address, because the computer does not understand it as memory. It does not understand it as the house. So for your computer to be able to refer to it, it refers to it using the memory address, which is an hexadecimal number. So let's print out the memory addresses. So we'll use another printf. The format specifier for address is the p. Okay, so we use p. Let's say address, and for you to get the address of any variable, you use ampersand. Okay, so address of a, and let's duplicate this, address of b, and address of c. That's the memory address. So let's put new line so that we have it all on a new line. So now we are going to see their sizes, and we are going to see their address, or where they are located in memory. New line here. Sorry guys, this happens sometimes. Okay, good now. So as you can see, each of these character, they have 1 byte each as their memory block. That is, each of these variable, they are stored in 1 byte of house. That is, they are in a house on that street. And for you to locate where they are located, if you want to give somebody their address, this is their respective address. As you can see, just in front we have FE, we have FED. So that's, we'll be having DEF. So it's telling you now that it is just 1 byte of address that these guys are using. 1 byte. That is why we are only having these changes just in front of the last, on the last characters. Let's assume we change this to short. So short is also a data type in C. So let's change it to short. Let's see how many bytes a short can store. I'll clear this, then let's rerun it. As you can see, a short stores 2 bytes. That is, a short is going to take 2 blocks in the memory. A short is going to take 2 blocks or 2 bytes in the memory to store just this value. Understood? A short is going to take 2 bytes or 2 houses inside of the street. A short will take 2 houses in the street so to store the person. And if you want to refer to it, you use the house address. This is it. Now look at it. We have the changes on 1E, 1C, and 1A. What if we change this to integer? So we have int, int, int. How many bytes will the int take? Let's see. Int takes 4 bytes to store. Int uses 4 bytes to store a value. So let's say it again. So in memory, to store an int is going to take 4 houses just to store, just to house the person. So let's assume int is going to be like a bungalow. So on that street in your memory, int is going to be a bungalow for the person to stay in. And for you to refer to the memory to address, you use p, and this is the address. So for you to say, you say this is the address of the int, of this integer a variable, and this is the address of this integer b variable. Now let's try another data type, the double. The double, save, and let's clear this. As you can see, the double takes 8 bytes, 8 bytes to store just this character. So you can understand how it works already. So inside of the street, the double is going to take 8 units to house this person. And this is the address in case you want to refer to it at any time. So how about we try this for an array? Let's say we create an array of characters. Char B, structure B, then let's declare the size. Let's say 3. It can store 3 arrays. Let's close this. We don't even need values. We can remove that too. Now, we're working with A and B. So the first one is a character. The second one is, we can leave it as character too. But the first one is a character. The second one is an array. So let's see what our result says. So you see that you use 1 byte to store a character. You use 3 bytes to store an array. And this is the address of the array. And this is the address of the character. Now, let's assume that our array is an int. Remember, int uses 2 memory space to store, right? So you'll see what happens now. Clear? You see 12. So you have 12. Oh, it uses 4, okay? And int uses 4 memory space to store. So you have 4 times 3, 12 bytes. It is a short, okay? Let's use short. Short will use 6 to store an array. 6 bytes because it's 6 times 3. So 2 times 3 is 6 because a short uses 2 bytes. Let's use short from up here so that you can see it properly. So short, let me clear. So to store one character, short uses 2 bytes. But in an array where you have 3 characters, the short is going to use 3 times 2 bytes to store it. Okay, so now let's try int too. And let's clear this. You see, an int uses 4 to store just one character, but it uses 12 to store an array of 3. That is 4 times 3, 12 bytes. And this is the memory address where you can locate each of the variables that are stored in there. So guys, that is it on memory address. If this concept is a bit difficult to understand, you may need to watch the video again or probably check other resources or get back to me in the comment section. Thank you guys. Hello and welcome to pointers. A pointer is a variable-like reference that holds a memory address to another variable or array. Some tasks are performed more easily with pointers, and on your screen right now you would see why pointers are great to use. So let's do it. Let's create an initial variable. Let's call it age. So let's say age is equal to 25. Okay, and like we've said before, using memory address, in every variable, there is what we call the left side and the right side. The left side is where the memory address is, or the address of this variable, and the right side, this one, is the value. So let's print them out. Print f. So I'm going to print out first the address of the variable. So to print address of the variable, let's say left side, okay, is equal to, left side is address. Yeah, left side is address. So let's print out the address. So to print out the address, you use P and you reference it with the memory address, so H. Then also, the right side is the value. Right side is value. And you don't need this. So let's print these guys out before we proceed. Oh, sorry, new character, new line. Clear output. So as you can see, oh sorry, format specifier is there. So we turn this back to D for integer. Alright. So what I've done now is I declared a variable, then I'm printing the left side, which is the address of age, and I'm printing the right side, which is the value of age. So let's see that now. So as you can see, left side is address, and this is the address, which is an hexadecimal number. And this is the right side, which is the value, which is 25. But like we just said here, we said a pointer is a variable-like reference that holds a memory address to another variable. That is to say, we can store this memory address of age in another variable, and that variable is called the pointer. So now the pointer would now point to the address of this variable. Remember we said before that in the memory blocks are like the houses. So your memory is a street. Then you have the memory block that stores the value or the person. Then inside of this, for all these memory blocks or all these houses, you have an address. So if you want to tell someone to visit you, you will be like number 23 Precious Avenue. That is your pointer. That is your memory address. So now we want to store that memory address in a variable. And the variable you store it in is called a pointer. So let's do that. So for you to declare a pointer, you always have to ensure that it is the same type with the character, with the variable that you want to store its address. So let's create a pointer. The first way to create a pointer is you can initialize it. Ensure that they have the same data type, int. Then you use a asterisk. Okay, you use an asterisk, which is called the indirection operator. Then I like to do mine like this, ptr. So because it's a pointer to age, so I say ptr pointer age. And this is going to store this value, this address, this one, ampersand age. So the first way to do a pointer is you can declare it as null. Okay, then you can now come down and say ptr underscore age is equal to age. Okay, this is the first way you can use to declare a pointer, these two ways, but I prefer to do it directly, so I'm just going to do it straight up here. So I will comment this out and just do it up here. So it's going to store the address of age. Okay, now it is storing the address of age. As you can see, now we have the first one, which is an integer variable, and now we have another pointer that is storing the address of age. So let's confirm if this pointer is truly storing the address of age. So let me drop down and print out let's print out the value of this pointer. Value of pointer ptr age is equal to okay, so the format specifier. So the format specifier here will also be a p because it's an hexadecimal variable number. Then we put a new line. We need the new line. Let me comment this one out. So we want to get now the value of pointer age, just to confirm. So we are also going to call the pointer here ptr age. So let's confirm it. Let me clear the output here and let's run this. So as you can see now, the left side is address. That is the left side, the address of age from up here is this, and also the value of the pointer age is also storing the address of age. Can you see that they are both the same address for both? So now you see that the value of our pointer is also the address of the variable age. Take note, the value of our pointer is also the address of variable age. And To confirm to you that our pointer is also a variable, we can also print the address of the pointer itself. Interesting, right? So we can do something like this. Let's say address of pointer is equal to P. And yes, the way we get address, ptr age. So let's run this. Sorry. Oh, print. Should be print F. So as you can see, the left side of our variable, this variable is the memory address, and this is the memory address. We got it right here. Then also, the value of the pointer, the value of this pointer is also the memory address of this guy. And to show you that our pointer is also a variable, we can also get the address of the pointer. Okay? Now, let's get the value of our age. And this is age here. We can get the right side already, which is the value, but also we can get the value of age through the pointer. And how do we do that? We use what we call dereferencing. So you say print F. So we say value at the memory address. Remember, the pointer is holding the memory address. Value at the memory address of ptr age is equal to. So right here we specify integer and we dereference it. We use star ptr age to dereference it. So let me put all these guys on new line so that our code will not be clunky. Then let's run this. As you can see, right side value of the variable is 25, and value at the memory address of ptr age is also 25. What have we done here? We've done what we call dereferencing. So what has happened is, remember we said that the pointer is a variable that holds the memory address. But remember we said before that the memory address is like the address of the house. And inside of the house, you can find what's there, the variable. So that's what we've done. From the address of the house, we've been able to find who is living inside of the house. That is what we call dereferencing. So through the memory address, we've been able to find the value. So let's go over it again. In any variable that you declare in C, you have a left side and a right side. The left side is the address of that variable, and the right side is the value of that variable. But also, you can store the address of the variable in another variable which is called the pointer, which we did here. And to prove it, we did it after declaring it and storing the value. We now have to print it out. So we printed the left side, which is the pointer, which is the address of the variable. And we also printed the value of the variable pointer, which also became the address of this variable. And to prove that the variable, the pointer, is also a variable, we also printed out the address of the pointer, which happens to be this. Then we went on to print the right side of the variable, which is 25. And to also prove to you that the value of the memory is in a memory address that you can locate through the pointer, we went ahead to dereference and print out the value of the variable age using the pointer. So it may look confusing at first, but if you take your time to rewatch these videos and just follow me through and understand the concept, it will become clearer. For me, it was difficult at first until I got to understand it, and I believe you will be able to do that too. Also, we can check out the sizes of the variables. So let's check the size of the variable age first. So printf the size of variable age is equal to, so we use size of age. So let me duplicate that. Then we want to check that of pointer. So let's say pointer ptr age So new line here to avoid issues, and new line here to avoid issues. So let's clear the output. So as you can see, the size of variable age is 4. An integer uses 4 bytes to store its value. But the size of pointer is 8 because a pointer is an hexadecimal number. As you can see here, hexadecimal. That is why it uses 8 to store its own content or its own variable. I just wanted you to see the sizes, that the sizes are different even though they are using the same data type. Also, guys, you can use a pointer in a function as an argument. So let's assume we have a function called print age. Okay, so print age takes in if an integer of age. Then let's just do something simple, printf, and let's say you are years old. Okay, age. So let's save that, and let's come down here and call this function. So we'll say print age, then let's pass a value to it. Let's say 30. So let's see what the function says here. I'm using a variable first before I use the pointer to get it. Okay, so let me clear the output here. So let's run this. You see, it says at the bottom here, it says you are 30 years old. You are 30 years old. You are 30 years old. Let me comment all these guys out so that it will be very easy for us to see. Okay, so let me rerun this using the function. So it says you are 30 years old. That is, we created the function, this function here, print age integer age, print f you are 30 years old. Then we called the function here, and that is why we have this result in our code. But we can actually do this also with a pointer. But even before doing it with a pointer, remember we have the age already here, right? So since we've declared the variable here, 25, age is 25, we can use age inside of here to replace this. So we have age. Or let me move this here upward so that it will be close by. So instead of typing the variable inside, like saying 50, we can just use age, okay? Then we can be changing what we want here. So let's change this to 50. We want 50 here now. So let's clear the output and let's reprint this. As you can see, you are 50 years old. So, like I said, we can also use the pointer instead of age, okay? And for us to use the pointer, all we need to do is just to replace age here with, first of all, we have to go up here and use the pointer. So we say pointer pt arrow age. Then we dereference it here too by calling it pointer pt arrow age. So what we are doing here again is dereferencing seen. We are dereferencing again. So for us to get it up there, we have to now call the variable ptr age here. And let's change the value in age. Let's confirm that we're actually getting it 76. Let's clear the output and let's run it again. As you can see, you are 76 years old. But we did not even use the integer age anymore. We used the pointer pointing to the address to dereference it indirectly and to get the value. Okay guys, that is it on pointer. I believe you've been able to understand it at least a little. So if it is not very clear, please rewatch the video again and try to follow through with the examples that I've done. Thank you guys. I'll see you in the next one. Hi guys, in this video we'll be talking about array. So array is a data structure that can store many values of the same data type, or the same data type. So previously we've been working with things like we say age, create the variable, then you say 24. But what if you have a lot to store? Let's say something like let's say we have price. Okay, so we say int price is equal to 23.0. But what if it's a store and there are different prices? There are so many prices. How do we get all those amounts stored? We use an array. So to write an array is as simple as saying int price, but instead of price we would now say prices because we want to store a lot. Then the brackets. This is the first way to initialize an array. Then you have to put in the size. Let's say 5. So we want an array of sizes of size of 5. Okay. So if you do this, it means that if you now want to start imputing the price, you have to do something like this. Prices 0 is equal to maybe 24.0. Then these are called indexes. So these are the indexes. So when you initialize like that, you want to do something like this 3, then you set all the prices. But this is too ambiguous. So if you want to initialize your array, the best way to do it is actually not to even set a size. Just leave it that way. Then open the brackets and start putting in the values, just like I'm doing now. So this is all setting up an array in C. So I'm setting an array with different amounts. I just want to be quick with this. Okay, let me add one more. So yes, this is an array in C. So instead of storing your prices one by one, you could also do something like this. Instead of doing it like this too, you can actually do it like this. So we have prices, and now we've been able to store different values inside of the array. So in array, all these values are set at different indexes. So this is index 0, this is index 1, index 2, index 3, and index 4. That is how it works in programming. So let's print out the first, or let's print out some of the indexes. Let's see what we have. So the first one is let's say price at price is so let's use this as a double. This is a double since we are using dots. So format specifier for a double is LF. Then we can put a $sign here. Then the amount you want to call out, you have to put it in the bracket. So we want the variable, we want the amount at this index, which is 0. Okay, so we say 0, save, and let's print that out to be sure that it is correct. So as you can see, it say price is this is 23. So let's just set the precision to 2 decimal places, dot 2. So let's redo this. So you see, it say price is $23. If we want to get this 96, how do we do it? We count. Let's say 0, 1, 2, 3. So that is index 3. Clear the outputs and let me run this. We will get 96. As you can see, that is 96. So, like I was saying, we can print out our different prices. So we say 0, 1, 2, 3, and 4. And let's print them all out. Oh, sorry guys, new line. So you see, we've been able to print out all the values of the array, or every value inside of this array, which you can see right now. But what if we have more values, like something like this? Let's just copy this and paste. It becomes a problem because we can't keep doing this copy and pasting, doing a lot of printf, printf, printf. So the next thing is we can loop through this array. Okay, we can do a for loop that is going to print out all the values of this array for us once and for all. And how do we do that? Remember, from our for loop, we create the loop for I equal to 0. Then, for us to be able to print out this array, we have to do a simple hack. So we say it's a simple hack. So the hack is we have to tell I to be less than size of the array prices, which will then be divided by size of prices 0. Then we set our increments to plus plus. Then now we can bring in our printf inside of the loop and change prices here, the index, to be I. So it loops through and it prints it all out for us. So what we have done here is we are saying I should be the size of the prices array, okay? And the size of should be divided by prices of one of the array. Let's do something quickly. I want to show you why I'm doing that. So let's get the size of this array. Let's print it. Printf format specifier bytes. So we want to get the bytes of this array. So we say size of the array prices, okay? So you understand why I'm doing this in the for loop. It says 80 bytes. 80 bytes, right? And how many numbers do we have here? 0, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are all equal because if we check the size of a double, so the size of a double is actually so if we check the size of a double, okay, the size of a double, let's put a new line here. You see, the size of a double is 8 and we have 80. So you see, each of them is just the same. So we have 80 here, and how many numbers do we have here? We have 10. So it's saying each one is taking 8 bytes times 10, that is 80. So that is why I have size of prices divided by size of prices of 0, like the first one, because any one of them is 8 bytes. Okay, so I can comment that out. Let's clear. So now let's bring back our for loop to loop over an array. So to loop over an array in C is what we have done. I is equal to 0, and I should be less than size of prices divided by size of one of the value plus the increment. Then you print it. Let's see, it's going to print out all our values for us now. So hopefully everything is right. So let's run this. Oh, sorry. So int I, we failed to do that. Now let's rerun this. As you can see, all our array has been printed out. The first one is 23.0 and the last one is 63.0. We just use the for loop to iterate over this array, and we've printed out all the values. So guys, that is it on arrays in C and looping over arrays in C. I'll see you in the next video. Thank you guys. Hello and welcome to this video. In this video, we'll be talking about two-dimensional arrays, three-dimensional arrays, or let's just say multi-dimensional arrays. These are arrays that are more than one, and each element is an entire array inside of an array. So a multi-dimensional array is an array of arrays, and it is useful if you need to create a matrix, a grid, or a table of data. So how do we create such array? Okay, we start by declaring our data type. Then we can say numbers. Then to do an array like this, you have to this is a two-dimensional array we want to create now. So we have to create two square brackets. This first square bracket is the row, and the second square bracket is the column. You may not need to set a number for this, but you have to set a number for this. So let's say 3 to start with, 3 columns. So to set up this array, let's start by going 1, 2, 3. This is our first array, or this is the first row. To create the second row, we say 4, 5, 6. Then we enclose everything inside of another curly braces. So this is a two-dimensional array. If I drop it down, you can see it properly. Okay, so let me drop it. Good. Now, as you can see, this array is looking like a table. So we have 2 rows here. You can put the 2 if you want, but let me put it just so that everything looks filled up. Okay, so this is an array that contains 2 rows and 3 columns. Okay, now how do we access the values of each array inside the index? We do this by saying printf, then the format specifier for integer. Then you can do something like this. So the 2 brackets, because it's a two-dimensional array. So let's get the first one, 0, 0. So you see, the first array is 0, and the value of the first array is also 0. So to get 1, we say 0, 0. And let's print this to see. As you can see, we got 1. What if we want to get 5? That is the second array. So that would be array 1 and 2. Oh, that's 6, sorry, 1, 1, 1. So let me just expand this so that we can see it properly.
So this array that we have up here can actually be visualized like this: 0, 0, 0, 0, 0, 1, 0, 2. Zero, 2. And the second one is 1, 0, that will be 4, 1, 0, 1, 1, and 1, 2. So just to make you see that it is the same, I will do it here. I will say, so 0, 0 is equal to 1, and the other one is equal to 2, 3. So I'm using the array again, using their indexes: 4, 5, 6. So I can comment this out because it's the same thing. What I've done here is what I've expanded to this. So this same array is also equal to this. Now, what if we want to loop through this array? Because it will be difficult for us to start, going in one by one. So what if we want to loop inside? But first, like I said, the arrays are the same. So we can just copy this here to initialize the variable. Okay. So this is what sets the groundwork for this array. It is set now. So we have an array of 2 rows and 3 columns. Now, to loop through this array, which is this or this, we have to use a nested loop, a for loop inside of a for loop. And how do we go about that? We say for I equal to 0, okay? Then for as long as I is less than 2, because 2 is the row, we are doing the row first, then I plus plus. Then inside of the loop, now let's create a new loop for our indexes. For our row. So let's call this one j. Int j is equal to 0. Then j, as long as j is less than 3, because the columns are 3, okay? Then j plus plus. And what do we want to do? We want to print out each indexes. So we will say the format specifier. And what are we printing out? We are printing out numbers I and j. And let's put a new line so that we have them all on new lines, okay? So I'm looping through the multidimensional array. Let's see if we get all these values back. So as you can see, it's looking like a table. 1, 2, 3, 4, 5, 6. Okay, let me put a space. So it looks like a real table. 1, 2, 3, 4, 5, 6. And as you can see, we have the same thing here. 1, 2, 3, 4, 5, 6. So I'm just trying to show you different ways we can use to initialize this array. Now, what if we added more to our array? Let's assume we now have a new column. So that would be 2, 2, 2. Some will be 7, 8, and 9. If we do this, our array is not going to loop properly over it because it's not going to go into 7, 8, 9 because we've hard-coded the rows and column here. So there is a way we can go about this. And how do we do that? We can set the values for the rows and columns, okay? So we can say, So we create the rows equal to, this is going to be the size of the numbers array, okay, which will now be divided by the size of the first index array, the index of the first array, and that is the row, and the column in scores, let me write it in full, will now be size of numbers of first array, size of numbers of each value. And now we can use them here. So instead of these two, we can change this to the rows and use these as columns. And now that we've done that, we should be able to get the value for all of our arrays now. No matter how many more arrays we had, it should loop through all. I think I've done it backwards. So first, let's print out the numbers of columns and rows. So let's be sure that we are on track. So rows, rows, okay, so this will be rows, and columns. So let's ascertain this first. I want to see something. Oh, new line. New line. New line, clear. So we have 2 rows and 2 columns. Okay, so because we added the new row here, so we have to update this. So you can actually make it 3 or leave it empty. So that was why we have this issue on our screen. So let's redo this. And as you can see, 3 rows, 3 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9 is working well now. So what if we remove this number here and leave it empty so that the script understands it itself? But I think it's better for us to put it. But let's just try and see if it works. It's throwing up an error. So we have to put it. So 3 by 3. So this array is a 3 by 3 array or a 3-dimensional array. That's what we've created now. Okay. So if we run the loop again, as you can see, we get our output and everything is working properly. What if we had one more row? Let's do that quickly. So this becomes 3, 4, 3, 3, and 3. And this is 10, 11, 12. Save. Clear the output. And let's run this again. Oh, see, we are yet to update this. So let's update this now to 4. Okay. So let's run it. And as you can see, we have 4 rows and 3 columns. See, 3 columns. And our arrays are in 4 rows. 1, 2, 3, 4. And we have 1 to 12. So guys, that is it on multi-dimensional arrays, 2-dimensional arrays, and 3-dimensional arrays in C. Guys, I'll see you in the next one.
Hi guys, so welcome. In this video we'll be talking about function. So what is a function exactly? A function is a piece of code that helps you to simplify your code, makes it easier and
definitely functions helps to avoid repetition. So let's create one. So you start with the header, include standard input, and let's do this. So we create our entry point function, which is main. So, you know, before we would do something like this, let's assume we want to do this. We want to print a lot of printfs. So we would have something like this. I would say hello x, you are welcome. Then maybe we do another one, something like hello x, you are years old. So basically, a function can help us take care of this. So maybe we could call this introduction. So when you have a piece of code that does a repeated task, you can actually put it inside of a function. So imagine we want to do this countless times. Okay, so I'm just going to copy and paste this. You can see how our main function looks like now. It's ugly. And remember, we said the main function is where every piece of code runs when you run the C program code. So it's not good that it's looking so clunky. If we run this, it's going to work. All right, you can see it's working, but then we don't want it to function like this. So what do? We can put all this piece of code inside of a function. All right, so I just want to put a new line character right here in front of everything. Okay, so like you see, it works. All right, it works, but then let's put this all inside of a function. So how do you create a function? The very first thing first is you define the function. So we'll say something like void, and the name of the function, let's say greeting, and that's it. So we have all our code inside of the function now. Then the next thing is we can now call the function here. And what is the function we are calling? Greeting. So all you do is just say greeting, open and close brackets, and that is all. And now that we've saved it, so take note, this is how you call the function, this is how you define the function, and this is how you invoke the function. So if we run this code, and you see that our code still works the way it's supposed to work. So guys, that is it simply on how to create a function, or how to define a function, and how to invoke the function. I'll see you in the next video. So guys, welcome to this video on argument and parameters in function. So from our last code we had this. Now let's clean this up. So I will just take out this and leave 2 lines so that the function is a bit smaller. Okay, so now here is a function that says hello x, you are welcome, you are y years old. Now what if we want to pass information to this? Okay, so what happens is, imagine we have the following. So let's create an array of name. So this is my name, and age is an integer. Okay. So we have an array of name and int age. What if we want to pass these values to this function? Let's try it out. So we'll change this to format specifier for string, that is for name. Then we want to have name here, and this for age, so this is for number D, and we want to have age here. Good. Let's run this and see if it works. Now you can see the problem. The issue we are having now is this function cannot see these variables inside here. So this is something you need to know. In function, there's what we call function scope, okay? So a function cannot see the variables inside of another function. So the only way you can be able to access variables through functions is either you declare them globally, or you use them as arguments and parameters. And how do we do that? So for this function to be able to see what is inside here, we have to set the parameters here. So we set the first parameter, which is going to be name. So we are saying this function is going to collect name, and it's also going to collect age. All right, but it's still not going to work because we've not done the second part. So the ones you put inside of the function itself is called parameter. So this function is going to accept two parameters. The first one is name, the second one is age. Then the one you pass to the function is what we call arguments. So now that we've declared it here, we can then pass them to the function. And how do you do that? You just say name and age. So if we save this and rerun this, let's see what we get on the output. Oh, sorry. And now you see the function works. Hello, precious Iriaevho, you're welcome. You are 100 years old. Also, you don't need to declare the variables initially. So if I comment this out, I can pass the figures that I want directly. So I could pass my name here directly. I would say precious, and age is going to be 50. So save, and let's run this. And as you can see, it still works. So guys, this is it on function, argument, and parameter. So when you create a function, you can also pass your argument, your parameters, and your argument, and this is how you pass them. All right, so guys, I'll see you in the next video. Hi guys, so welcome. In this video we'll be talking about return statements. So you can see already we already use a return statement in our main function. All right, so let's do that and let's see it again. So right here we say int main, and we have a return statement here that says 0. So this is the exit point of our function, our main function, that shows that the function or the code has run successfully. But also in the functions that we create, okay, we can also return statements to be used in another function. So you can create a function that returns a value that can be used in another function. So how do we do that? Let's assume previously we used to have something like void. Then let's say what should this do? So let's say square. Let's say square num, and it's going to take the value of x, just one x. And what do we do with it? So this function, all it does is it gives you the square of a number. All right, so we'll say something like, let's say we want this as a double. Okay, so x times x, so it's giving us the square of x. Okay, so double num, so we'll call this double num. So num is going to hold the value of x times x. Now if you want to use this function, like you want to return the value to be used somewhere else, all we need to do is to say return what? Return num. So we are returning num now, and now that we are returning num, if we call this variable here, if we call it, so the variable is square num, you can see that we need to send in an argument. Okay, so what argument we are going to send? Let's send in 9. All right, let's check what we get on the outputs. Okay, so you can see the very first issue we have here is the void. Now that you are returning something, you cannot call it void anymore. You know why? Because you are returning a value. So we have to let it match the value of what we are returning. And what are we returning? We are returning a double. just like here we are returning an integer. Okay, so here we are returning a double, so we say double, and let's rerun our code. And as you can see, there is no value. And why is that? That is because we are returning the value, but we are not using it. So now the function is working properly, but now we need to use the return value that we have set. Okay, so how do we use that? We can create a new variable here and just say something like, let's call it another double. So we are collecting the double here, and double square, so we can call this square. Double square is equal to square num, and now we can print out the value. We can do anything we want to do with it. So we can say the square of 9 is the formal specifier of a double and square. Okay, and now let's run this. And as you can see, the square of 9 is 81. All right, so this is basically how to set a function, give it a value, a parameter, and get it to return a value to the main function. And when you get to the main function, you accept the value by declaring the function, and you can do anything you want with the results of the returned value from the initial function. So guys, this is it on the return statement in functions. I'll see you in the next one. Hello and welcome to this video on function prototype. So what is a function prototype? Actually, it's a function declaration without a body, and it comes before the main statement. It ensures that calls to a function are made with the correct arguments. So let's do something. So let's move our function to the bottom, all right, so that we can see it properly. And now that we are declaring the function, let me give it just one value. So normally this function is going to accept 2 parameters, right? But I'm going to pass in just one parameter. Then I will save and run. Let's see what happens. As you can see, our function still runs. Hello precious, you're welcome. But then for my age, because I did not pass in age, it just gave me a value. I don't know where it's getting this value from. And this is wrong. You know why? Because if our function is not getting the right number of arguments, it shouldn't run. And that is one of the things that the function prototype is going to solve. So for function prototype, all you need to do is just to declare that same function at the top, but without the body. Okay, so we say function void greeting, then the parameters is supposed to accept. So let me just copy these guys here. And now let's try to rerun this function. And as you can see, our function did not run anymore because we've used a function prototype. So as you can see, it ensures that calls to a function are made with the correct argument. But now if I put in the right argument, let's say age of 70, and I run this now, you can now see that our function runs correctly. So that is it on function prototype. But some important notes: many C compilers do not check for parameter matching. You see, and that was why our code ran previously. And you see, it's not a good one because missing arguments will result in unexpected behavior, whereby it gives you gibberish as a return. And also, a function prototype is going to cause the compiler to flag error if arguments are missing. So you see why you should use it. Now, advantages: with function prototype, it is easy to navigate your program with your main function at the top. So if you have this main function at the top of your program, it's going to be very easy for you to, navigate around, to know what you have inside of that program. And also, it helps you with debugging, and function prototype are commonly used in header files. So when you encounter header files, you would know why function prototypes are used frequently. So guys, that is it on this video on function prototype. I'll see you in the next one. Cheers. Hey guys, so this is array of strings. Normally when we want to set an array, we do something like this. We say name but this is a one-dimensional string array. So if you want to set a two-dimensional string arrays, let's say names of cars, then you do something like this. So because the first one here, the names itself, they are arrays, and it's an array inside of an array, so it's a 2D array. So that is why you have to do this. You have to set the first array and the second array. So that makes it a 2D array. So if you want to do something like transversing this kind of array, you won't be able to do this initially by saying car 0 into Tesla. You can't change the value. Instead, you have to use the string copy function from our string functions from the last video. So if I run this now, so when you do the string copy function, save, sorry. So you see we've been able to change Mustang from Mustang to Tesla. So what did we do? We used the string copy function, checking the array at the point 0, which is Mustang, and we turned it to Tesla. And for us to be able to access it, we transverse the array using the for loop, and using size of cars and size of cars of one of the array, we were able to get the size of the entire array. Then we incremented it with plus plus, and we print F all the result, and that is why we have Tesla, Corvette, and Camaro. So this is an array of strings, which is a 2D array of strings instead of the normal one array of strings. So this is a 2D array of strings. That is why it is an array of strings. So I just felt I should talk about this. So I'll see you in the next one. Thank you guys. Hey guys, so we know how to create strings already. You know, this is how you create your strings. And I feel now that we've discussed about functions, it is right or the proper time for us to talk about string functions. So string functions are actually functions that you use in transversing your strings, just like we had in our math function. So in the first one, in string function, so for you to use string functions, you have to import the string.header file, okay? If you don't have this file, your string functions won't work. Now the very first one we have is string to lower. Okay, so this converts a string to lowercase. So let me convert everything here in string 1 to lowercase. So I have my P arrow in capital letter. So let's check that out. And as you can see, everything is in lowercase already. And the next one is it converts everything to uppercase. Okay, so let's comment this out. Let me clear this. Then string to upper, this converts everything to uppercase. And as you can see from this, we have this all in uppercase now. The next one is string cat. So what does string cat does? String cat appends string 2 to string 1. So it will append this second string to the first string. So let's try this. Oh, sorry, string cats. I didn't uncomment it. So it's uncommented now. So let's do that. So as you can see, we have precious Iriaevho without space, and that is what cat does, string cat. Now, what if we want to append just some characters from the second one to the first one? So maybe I want to append just this, my first 3 letters. I can do this by saying just 3 here. Okay, clear. And as you can see, precious Iri, because I said 3 letters here. Okay, so the next one is string copy. So string copy is going to copy string 2 to string 1, and let's see that in action. So let's copy string 2 to string 1, and string 2 has replaced string 1. All right, so what if you don't want to copy everything? Let's say we want to copy just 3 characters. Clear, run. And as you can see, Iriaevho. So these first three characters, I've replaced PRE, and now we have Iriaevho. Never thought of that. And let's go. Then the next one is string sets. So you use string sets to replace all the characters of a string to another character. So let's say we want to turn everything to question mark in string 1. And as you can see, everything is turned to question mark in string 1. What if you want to turn just some characters in string 1 to X? Let's say 5. And as you can see, just 5 of it have been turned to X. Also, string reverse is going to reverse the string. So let's see how that works. So you see, my name Precious has been reversed from the back to the front. That is what string rev does. String reverse. Then also, this is an if statement, and we will be using this with this. So we have int result. We have something called string length. So to get string length, it's going to return an integer. So let's do this first. So string length of string 1, since this is an integer, so we have to turn this to D, and let's see what it returns for us. Oh, there's an error. So string length of string 1, so int result, sorry, so this is result. Okay, so let's clear this. And as you can see, we have 8. That is the length of the string. So if you count Precious, you have 8 characters in Precious. The string compare is used to compare all characters. So you can check if they are matching, and that is why we have the if statement. So if okay, so result. So we want to compare if string 2 and string 1, if they match, okay, but it should return 0 because they don't. So these strings are not the same. You can see if the result is equal to 0, these strings are not the same. They don't match. Precious and Iri don't match. So same thing, it compares, the other one compares some characters. So this one can compare, let's say, the first character to what we have, and it will still be 0 because they don't match, okay? So you see, these strings are not the same. So guys, this is it basically on string functions. There are a lot of other functions inside of the string.h header file, but for now, these are the common ones that you would use, and if you want to learn more, then you would have to go out there and do some more research on your own. So guys, I'll see you in the next video.
Hey guys, so welcome. In this video, we'll be talking about struct. So struct is a short form of structure, and they are collections of related members or variables. Unlike arrays, they can be of different data types, and they are listed under one name in a block of memory. And they are very similar to classes in other programming language, but you can't use them in methods. Okay, so let's create a struct. Let's assume we have some series of students. So we can say struct. This is how you create a struct. Then let's say students. Okay. So students is going to be the struct name. Then what do we want to store for the students? Okay. So if we have students, definitely we want to take their names. Okay. So we'll have names or name. We can give that a size of 20. We also want to take their age, and probably we want to take
their country. Okay, so this is an array of strings or array of characters, so we have to give this a size too. And now that you have the struct, so you create the struct just above your main. The next thing is we have to access the variables inside of the struct. So for us to be able to access the variables inside of our struct, we have to use the struct name. So we can do something like struct students, then we can say something like student1. All right. So what we are doing with this is like trying to initialize. So let's create another student, so we can call this student2. Now, how do we assign values to the variables? So for student1, since name is an array of character, we can use strcopy. Then we use student1 dot name because it is name. Okay, so we are trying to give value to the name of the student, the first student. So we can say the first student maybe is Precious. And also, let's give the age. So for age, since it's an integer, we can do this like this. Student1 dot age is equal to 50. And we can also do the same thing for country because it is an array of characters. Okay, so we use strcopy. Then we say student1 dot country, and this student is from Nigeria. And now we have that for student1. We can do the same thing for student2. So we can just copy everything and paste. So we can change the name. Student2 probably will be gold. Country, age maybe 70. Country, let's say Ghana. And now we can, since we've assigned values to the variables in the structure, we can then decide, or we can actually access them using the printf now. So let's do for student1, let's print something for student1. We'll say student1 name is, remember the format specifier is, and he or she is, we are going to put the age, and he or she is from, then string again, new line. So the first one is student1 dot name. The next thing we want to access is student1 dot age, and last but not the least is student1 dot country. Okay, so student1 name is, and he or she is years old, and he or she is from. So we can duplicate this for the other students. So we can say student2 name is, he or she is from. So we change the variables, the structs 2 and 2. So let's run this and let's see what we have. Oh, I did not change this, so it should be student2. Okay, student2, student2, and student2. That's why we have this error here. So let's redo it. So I'm going to clear this and I'm going to run this again. So you see, student1 name is Precious, and he or she is 50 years old, and he or she is from Nigeria. Student2 name is Gold, and he or she is 70 years old, and he or she is from Ghana.
So exactly what we've done here is what we can see on our output. So the first thing we did was we declared our struct students with different variables. Then we assessed it, we created different students, then we gave values to them and we printed out their values. So that is it on structs, guys. I'll see you in the next one. Cheers. So guys, we want to talk about type def or type definition, and this is a reserved keyword in C programming that gives an existing data type a nickname. So, most times when we want to create our array of characters, we could do something like name 50 is equal to, let's say, precious. But with type def, instead of typing out all this, we can just decide to give it a nickname by doing something like type def. Then we say name. Okay. So the array type, so let's say 50. All right. Or let's use user. So we have a type def of char, a user. So now that we have this declared with the type def, we can always use it here and say something like, so we say user. So you call the type definition, then you create who you want to create. So we say user1. But this is for an array, but type def is mostly used in struct. So from the struct from our last class, so let's use that. I still have it up here. So if we want to use type def with this struct, all we need to do is just to rewrite this. So the first thing we need to do is to take out the we should take out the struct name, okay? So we take out the struct name, so students, we just copy it or cut it out. Then you put it right here. Then right before struct, you put type def. So what we've done now is we've created a type definition of our struct. And now, if we want to use it, all we need to do is just to come down here. So we come down here and just do this. We say students, then we can undo student1 is equal to, so let's assign some values to the variables. So we do precious again. Age is 80 and country is Nigeria. And let's create another student. This one should be from Kenya, probably 90. And let's call this Silver, and we'll change the student name. So student 2. And now we can access all the values. So we just do a print f. Okay, so I'm going to access everything for student 1. So I'll just say student 1 equal to, so name, we get the name, we get the age, and we get the country. All right. So now we access the variables student 1, and the first one is name, student 1, age, student 1, country. Okay. Yeah, that was an error. Then we can duplicate and say student 2, 2, 2, 2, and let's put this on a new line.
So save and let's run this. So there's an error somewhere, printf. So let's try to troubleshoot. Okay, so I think we did not close this, so semicolon. So save again, I clear the output, then let's run this again. And as you can see, our code has worked correctly. Student 1, Precious 80 Nigeria, Student 2, Silver 90 Kenya. So just a recap, you use a typedef to make your code simpler. And we did a typedef of the struct students, then we assessed it and assigned values to the variables. Then we printed out the values of the variables here. So guys, that is it on using typedef with struct. I'll see you in the next one. So hello guys, in this video we will be talking about array of structs. So let's assume we have more students and we want to get more information about them. So I'm going to copy this, still working with our previous code from our previous class, typedef. So now we could say this student name could be, we could use gold again. And now we could call this student diamond. So I may just change the age. Now, to create an array of structs, all you need to do is just to go on and say, all right. So since we have the typedef, all you do is just students. So that's the typedef. Then we create an array of students, okay? You may give it a size or not. Then let's call in all our students. So all the arrays, so students 1, that is all the various struct that we created. So this is 3 and this is student 4. So I'm just going to copy this, paste that, student 2, okay, so this will be student 3 and student 4. Now, since it's an array, we can actually look through to get access to the different information of the various students. So how do we do that? We use a simple for loop. So we initialize I is equal to 0 as long as I is less than, so we say size of, okay, so size of students, that is the array, divided by size of students and one of the arrays, so 0, and we increment I. So what do we want to print out? Let's print out the names of the students first. So format specifier for string is S. Let's put this on a new line. And to access all the students, each student, so we say students I, okay, student I dot, so the first one there will be name. So let's see if we can access the student name. It should be students, yes, to students name. So let's see if we can access that claim. All right, so I renamed the file properly. So let's redo this. So save and let's run. So as you can see, we just accessed the student name. Let me clear and redo it. So I'm going to run it again. And as you can see, we have precious, silver, gold, and diamond. So we've been able to use the loop to loop into this to get the various names of the students. All right. So that is how to get information from an array of structs. So let's try to see if we can also get the age. So all we do here is just to say age, and the format specifier is D. So I'll clear this and let's run this. So you can see we've been able to get the age, but let's make this better. So instead of a new line, we can say tab. Okay, so let me clear this. And there you have it. So we have Precious tab 80 and Silver tab 90. So you have the student's name and you have the student age right in front of it. So that is how to access, that is how to create an array of structs, and this is how to also access the variables or the values inside of it. So guys, I'll see you in the next one. Hey guys, welcome to this video. And in this video, we'll be talking about enums or enumerations. So enums are a user-defined type of named integer identifiers, and they help to make a program more readable. So let's do an example. You can define enum outside of your main function or inside of your main function, or outside of your function or inside of your function. So let's do an enum about days. So you use the keyword enum, and let's say days, then you open a bracket, then let's go through Sunday to Monday. All right, so Sunday, Monday. I'm not going to use the words in full. Sun, Mon, so Tuesday, Wednesday, Thursday, Friday, Saturday, and okay, run full circle. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So this is how you create an enum. Now, when you have your enum, just like your array, the very first value is set to 0, okay? And on like that. So when the first one is 0, you have 0, 1, 2, 3, 4, 5, 6. That is the values of the enum. But you can actually set them to something. So you can set Sunday to 1. So let's do that. We could say Sunday is equals to 1. So instead of it being 0, we can make it 1. Then we do that for the rest. So this is 2. So 3, 4, 5, 6, 7. So if you leave it without setting the values for them, they will all be from 0, 1, 2, 3, 4, 5, 6, 7. But if you set your values, then you can control what values they would be. So let's print out one of them. So for you to understand, enums, though they are like characters or strings, but they are treated like integers. So let's print out the value of one of them. So let's say something like, so we use the format specifier for numbers. Okay, so let's print out the value of one of the enums, right? But before we do that, we have to use the enum. So we have to declare it. So you say enum days. Okay, that's the name of the enum. Then let's set it to a variable. Let's call that today. And we can set today to, let's say, sun. No, let's use when or Thursday. Let's use Thursday. Okay, so it's equals to Thursday. Now we can print out the value of this enum. So we say today. And let's see what comes out for us. So I'm going to run this. And you see 5. And as you can see, Thursday was set to 5 here. Let's try it again. Let's turn it to Tuesday. So you say it's 3. So you see the enum value is used as an integer, not as an array or a string. Now, for you to understand how this would work properly, let's use it in an if statement. So let's say we have an if statement. If today is equivalent to 1, remember 1 is Sunday, or today is equivalent to 7, so you know 7 is Saturday,
Then we can do something like say, it's the weekend, no work. Okay. Then else, every other day, we'll be going to work, right? So printf, I will be in the office. So I've saved that, and let me clear this. So we are using the enum value to access them. So today is 1, that is today is Sunday, or today is 7, or today, that means today is Saturday. So if it is any of those days, then it's a weekend. Else, it is anything else. So remember, we set our enum to a Tuesday here today. So let's see what it prints out for us. Sorry. Yeah, out there. So let's run this. Printf, print. Let's do this again. So you see, I will be in the office. Why? Because today is set to Tuesday, and Tuesday is 3. So Tuesday is not 1 or 7. That means we are going to be in the office. So let's turn this to, say, Sunday. So sun, and let's run the code again. And you see, it's the weekend, no work. But also, like we said, enum is to make your program readable. So what if we turn this to sun, and we turn this to sat? So you can actually use the names of the enums, not just their values. Okay, so let's run this. So we are using the name right now, and you can see it's still the same. It's the weekend, no work, because today is sun, or today is Saturday. So guys, not to make this video so long, this is how to use enums or enumerations in the C programming language. I'll see you in the next one. Thank you. Hello guys, so welcome to this video, and in this video we'll be talking about writing to files. So in this one we'll be writing and deleting a file. So let's create our structure quickly. So for us to write to file, we have to use the keyword file. Then we create a pointer to a variable that we want to use to hold that. Then you use the function called fopen. Okay, so for the first one, we put in the file name. So let's say test.txt. So this is going to be the file name. If the file does not exist, it's going to create it. And if the file exists, it's going to either write to it or overwrite what is in it or delete it. So the next thing are the parameters we use this is the other parameter, and we use this in creating or writing, reading or appending. So the first one is append. You can choose to append, you can choose to read or write, and we'll be using write. Okay, so it is important that every time you open your file that you should also close it. So you close it by saying fclose. Okay, fclose and the name of the file. So fclose tst. So instead of using the tst, since we've used a pointer variable to access we've assigned the values to a pointer variable, we just say pf here. All right, now it's time to write to the file. So to write to a file, all you need to do is to use the fprintf function. Then the first thing is, what file are you writing to? So we are writing to the file that is stored in the pointer variable. And what are we writing inside it? So let me just write in my name inside. So Precious Iriaevho. So before I do this, let's not forget our return statement. So before I do this, let me just run you through what has happened. So for me to write a file, first I could have done it like this. Fopen, let me take this out. Fopen, but I needed to assign it to a variable so that I can reuse the values. Okay, so now that we've written the variable, so I use the keyword file,
Then I used a pointer variable. Then I stored the fopen function with the two parameters. So it should create a file called test.txt and it should write to it. And what should it write to it? It should write precious Iriaevho to the file that is stored at this variable. Then after writing, it should close the file. Okay? So take note of the left hand side. I have nothing here. The last file I have here is 034. You see, nothing else. They are all well numbered. So I'm going to run this now. Let's see what happens. As you can see, the file has been created, test.txt. I did not create this manually. If I open it, you can see my name is inside of it. So let's do it again. Let me change it to something else. Let me say I am from Nigeria. Okay, take note of the test.txt. And I'm going to run it again. Now let's check what is inside. And as you can see, I am from Nigeria has been written to it. So it has replaced what was there previously. So if you don't want to overwrite, you use A to append. So I will append something to I am from Nigeria. So let me say I am from Nigeria, the new line. Nigeria is the giant of Africa. Save. And let's run this. And let's check our test file. And as you can see, I am from Nigeria, and Nigeria is a giant of Africa has also been appended to the file. Now, how about if you want to delete the file? So if you want to delete the file, we can do that with an if and else statement. So we say if, then we use the remove function, okay? Remove. So remove test.txt. If it's equal to 0, that is if the exit code is equal to 0, then we should print out something. We can say file deleted successfully. This is deletion. Else, we can say something like maybe file does not exist anymore. All right. So we are trying to delete the file. So let me comment this out. So if remove test.txt is equal to 0, if the exit code is 0, that means the file has been deleted. Else, it does not exist. So we are trying to delete a file that does not exist. So take note of my test.txt. And if I run this code now, and as you can see, test.txt has been deleted and it says files deleted successfully. If I try to do it again, it says file does not exist anymore. So guys, this is it on how to create a file, write to it or append to it, and also how to delete a file in C programming language. So guys, I'll see you in the next one. Thank you. So hey guys, in the last video, we talked about how to write and delete files in C. In this video, we'll be talking about how to read files in C. So let's get to it. So we say file, then you assign it to a pointer. You can call it anything. Then the fopen function. Then the file you want to open. And the parameter is R, so you're reading. But this file does not exist, so let's create it quickly. Test.txt does not exist, so I'll create it. And I'm going to put some stuff inside, so I'll say I am precious Iriaevho. I am Nigerian. Nigeria is a great country. I love my African brothers and sisters, and you too watching me. Okay, so that's just a simple file created with tests. Now we can open it. So now that we've created it, the next thing is we need a buffer to be able to, read the file. Okay, so we have to assign this to a character variable. So we say char, we can call this buffer, and we can assign values to it. So I can just say this is 500. So I used the wrong brackets. It's an array, don't forget. And don't also forget, we should always close our file immediately we open it after we are done. Okay, so F close. So that should be at the end there. And now that we have the buffer set, we can read the content using fget. You remember fget? So it's small letters, so fget. So the first thing is what we are reading, buffer. Then the size is 500, and we are printing it out to the pointer pf. Okay, so now let's print out what we have there. So printf, remember it's an array s, and we are printing out buffer, but this is going to print out one line. Okay, so let's see. Printf. So let's run this, and you see it's only printed one line. So for us to be able to print out all the lines inside of our test file, we have to put this in a while loop. So let's create a while loop here. So while, then inside of the function, we put our fget, and we say if it is not equal to null, that is, if it has not gotten to the end of the file, then it should do what? It should print the buffer. So let me delete these spaces, save, and let's do this again. And as you can see, everything in the file has been printed. I am Precious, down to you two watching me. Okay, so we can also test if the file exists before we even do anything. So let's check if our file exists first before we even try to read content from it. We can use an if, we'll use an if statement after buffer. So we say if pf is equal to null, that is, if it does not exist, then we print what? We say file does not exist. Then what should we do if it exists? We do everything inside of our while loop. So we put the while loop here. Okay, so let's try to run this now. But first, let me clear this place. Okay, cleared. All right, so what I've done is we try to open a file that exists, then assign it to a buffer. Then we put an if statement that if the file is null, that is, if the file does not exist, then it should print file does not exist. But if the file exists, that is else, then it should print out the content. So let's change this. Let's do this to test.txt, which does not exist. And let's see what it prints out for us. So you see, it says file does not exist. What if we use a file that exists? Test.txt. I've just changed that. Let me clear this. So you see the file exists and it has gone in to print out the content of the test.txt file, which is this. Okay. So guys, and it has closed it. So guys, this is it. We've been able to write to a file, delete a file, and now we've just been able to read content from a file in the C programming language. So guys, this is it, and I'm happy to run this course or this journey with you. I'll see you in the next programming language. But definitely we'll be doing a lot of projects inside of this C programming language courses. So be back to check all the projects that we will create. So guys, this is it, and I'll see you in the next one. Thank you.